Have you ever wondered what happens after your application goes live? You deploy your app, everything looks fine, you just start signing up, and then something breaks. But the problem is you have no idea what broke. Was it the database or was it an API? This is exactly why companies spend billions of dollars every year on monitoring platform tools like Datadog, New Relic, or Sentry. These tools help developers understand what's happening inside their applications in real time. They collect logs, track errors, monitor requests, and alert you before things get out of control. And today in this video, we're going to build our own production-ready monitoring SaaS platform from scratch. A platform which is capable of ingesting thousands of logs, streaming them in real time, searching them instantly, tracking uses, and sending alerts when something goes wrong. By the end of this video, we'll have a complete monitoring platform that looks and feels like a real SaaS product. Alright, welcome back to OneMinute Logs. This is the landing page of our application monitoring SaaS tools. And the name is OneMinute Logs. But why the name is OneMinute Logs? The name is OneMinute Logs because the target of this monitoring tool SaaS is that you can set up our platform under a minute. That's the main goal of these applications. There are already so many application monitoring tools on the market such as Datadog or Sentry and many more. And most of them are actually targeting the advanced level projects or the advanced developers. And on the other hand, we are targeting the small scale applications or the new startups who just want to track their applications without headache. And you can easily understand that by watching our landing page. You can see this is the first section or the second section. It's not the first section. First one is hero. In the second section, we are saying why OneMinute logs exist. So logging should not feel like a whole other job. Most devs don't have time to babysit logging stack, ELK, random dashboards, or the YML jungles, all just to answer one question, and that is what went. So if you're shipping fast, or if you're junior, indie, or side project, or small team, and you don't want to spend days writing logs, you just want errors, requests, and latency in one place instantly, and then for all of you, OneMinute logs remove all the overhead. Drop in a small SDK, deploy, and your log starts streaming under a minute. No servers, no cluster tuning, or no 40-page docs before anything works. So you can easily understand why we are making OneMinute logs and whom we are targeting. After that, which features we're having. So we are having the capture and store instantly. It's like you can store your logs instantly. And interestingly, we're having a very high ingest capability. You can see 2 million plus logs per minute. It means our platform is capable of handling more than 2 million logs within every minute. Since we are a startup, this is definitely a very big number for us. And you can see less than 50 millisecond average search time, which is also another very good number. And after that, if you come back to here, we have live log stream, like the log tail you can see in here, the same. You will basically get the live log streaming. You don't have to wait for any like milliseconds. It's literally like the live streaming for your logs. And smart alerts and webhook, very important features. It's like when, like, let's say there are an X errors, if it's coming, let's say more than 50 times or like set number, then you can basically go to our dashboard and you can set some alerts that if this error is coming more than this number, then send us an alert, and we will basically send the alert through the webhooks. And that's why here smart alerts and webhook. And this is the setup requirement. You just have to install the package, initialize the logger like this, and then start to sending logs. That's how much easy setting up OneMinute logs actually is. Now these are some like reviews and some like our pricing, which is also very like affordable. And after that, it's like get started and view docs. So let's go back here and let's hit get started and let's sign up. All right, here you go. Sign up is actually done. Right now I can click here and you can see dashboard, billing, settings, and support. So I'm hitting this dashboard button from here. It's taking me to another tab, and here you go. This is the dashboard. It's currently looking completely empty because we don't have any data yet. This is a very new account. Definitely there's not going to be any data. Here you can see the last 24 hours logs, your error rate in that logs, ingest rate. So ingest rate is basically like how much logs we're ingesting in every seconds. Active alerts, like your alerts, when you're having some alerts, you'll be able to see the number in here. The average latency of storing the logs, the queue backlog, the amount of logs currently like in our message broker. So you'll probably not understand all the cards in here, but don't worry, I will explain it more clearly in the system design part. And in these top sources, it's like the source of your logs, the error train, like it's on chart. Same for the logs over time. This is like top activity from the last 24 hours. And this is like our internal service, like the ingest service, alerting service, the database and public API. And these are like the recent alerts. This is the live logs. Now you're probably going to think why we are having here some data. We're having some data because when I was testing this application, I already added this data. I can show you how I was testing it. You have to go something like this on 3001/API/test. And here you go. You can see user ABC logged in and it's instantly in here without any reload because it's fully real time. Now, how it's working because in our API test and route.ts, you can see in our project, here we added on get endpoint and we're saying logger.info and send this message that user ABC logged in. It's just for testing purpose so that we can test it perfectly from here. And after that, from here, you can basically run some queries. Let's say you want to filter out only the type error and you can hit run query. You can see we're having all the errors in here. We can again clear the query. So you can write like your app name or type or anything like for queries. It's just like a statement for finding out some data from your logs. And then this is the alerting system. You can basically create a new alert from here. These are the integration. You can set up it with Next.js, Express.js. Nest.js is actually working. It's saying coming soon, but it will work at the end of this video series. And API keys, this is another important part. By using these API keys, you can set up our application inside your project and you must need these API keys. And after that, we have settings in here. Like you can change your billing plan and like the project setting, account and security and the danger zone, like for deleting the account. And that's all. It looks very small on the front end side because the SaaS itself is application monitoring tools. So the maximum amount of work is actually in the backend. Like we need to have a proper ingestion setup. We have to work with event-driven architecture and so many things. And I'm super excited to show you how we're gonna make this application and how the real world application monitoring tool SaaS actually work under the hood. So this was the short demo. I definitely don't want to waste a lot of time by showing up the project. I want to give the time for building the project. But before starting to coding, you should definitely understand how this application is actually working behind the scene, like with a system design pattern. So the next module is going to be the system design for this application. So let's start it. But before starting the system design module, one thing I'd like to let you know, everyone know that AI has changed how we work in almost every area of software engineering. Now we use AI to write code, review code, and automate most of our repetitive tasks. But when it comes to email, most people are still doing everything manually. And that's a problem because work doesn't stop when you leave your desk. Email follows you everywhere, whether you are traveling, working from a coffee shop, or taking a few days off, your inbox keeps growing. That's one of the reasons I recently started to using Superhuman Mail. Superhuman Mail is a part of the Superhuman Productivity Suite, and it helps remove a lot of friction that normally comes with managing email. For example, instead of manually digging through old conversations, I can use Ask AI to quickly find information from my inbox. It can also help with things like scheduling meetings, checking calendars availability, and keeping track of important conversations without spending time searching through everything myself. Another feature I like is Write with Voice. I can describe what I want to say in my own style and tone, and Superhuman Mail turns it into a polished email draft that's ready to review and send. What I like most is that it helps me spend less time managing email and more time focusing on actual work. If you'd like to try it by yourself, just head over to superhuman.com/Becodemy and you will get an 1-month free trial. Now let's back to building 1-minute logs. Alright, in this part of this video, I'm going to talk about the system design for 1-minute logs. Yeah, it's very important for you to understand the system design before starting the application, because otherwise at the end of this video or in the middle of this video, you'll feel like what the hell you are doing and where actually you will end up, like in the video, like sorry, not the video, how you will end up the application. What's the like main goal for this application? So first of all, you have to understand that we are not making it for users. Yeah, it's different. Like let's say if you're thinking about an application which based on users, like an e-commerce application or edtech platforms, all of them are for users. But 1-minute logs, it's not for users, it's for application. So it's for your application. So logically, you are our user. No, it's not true. Your application is our user, or like the client, we can say, for our this project. So your application is like our users, we can say. But the question is how you are using it inside your application, how you are going to use 1-minute logs inside your application. You're going to use 1-minute logs SDK, which is something like an npm package, you can say. Now the question is, when you're using the 1-minute logs SDK, what is the goal of this npm library? You can already like see it on the name. It's 1 minute, meaning you can set up logs under a minute. So in this SDK, our main goal is going to be, or not only in SDK, in this full application, our main goal is to be that you can set up this application under a minute. And that's why the name is 1-minute logs. Otherwise, there is already like Datadog, there is already so many big companies like I was explaining, I was giving example in the intro part, there is Datadog, there is Sentry, there are so many applications on the market. But our target is different. We're like offering that you can set up these logging applications under a minute. But definitely it's not an easy task, which completely makes sense because logging is not a simple thing. But my point is, yeah, it's not a simple thing, but we can make it simple. We can make it simple, we can make it complex also. It depends on your application. For a small application, for an early stage SaaS, definitely they don't need to create or write like on schema for setting up their logging mechanism. They don't want, they probably just want to like track info, errors and warning. That's all they want. They don't want to write like a complicated schema and set up it, just read the documentation, waste a, let's say, full day for setting up on logging application. They don't want it. And that's where 1-minute logs will work. Now, inside this SDK, you can see we will have some methods. That's why like info, error or warning, you can just say like logs.info, and you can import logs from 1-minute logs SDK, and you can just write your message and any other properties if you're having. You can just add that. And then we will send that to our ingestion API. Now, why ingestion API and what is the meaning of this ingestion API? It could be also REST API, or it could be also middleware, because the first stage definitely should be the middleware. And logically, our first stage is still middleware or the guard. But then why I'm saying here ingestion? The reason behind it, we're actually following here on ingestion mechanism. What is the meaning of ingestion mechanism? We're following here on event-driven architecture. What's the reason? Because think about it, since application is our like user, it can happen that we're having 10 or 20 applications. I'm saying a small number, let's say 100 or 500 applications. They are using 1-minute logs in their application. And when they're having users, let's say they are having, for an example, let's say 1,000 users on average. They're having 1,000 users on average, and 50 or like 500, then it means like probably 50,000 or more than that users requests are coming to our API. Because when their users are doing something, those requests are coming into our 1-minute logs SDK through our API. It means our API must need to be highly scalable because it's receiving a lot of pressure. And the interesting thing is that 1-minute logs can easily handle millions of logs within every minute. Yeah, it's that much powerful. It can easily handle more than millions of logs. But how is that even possible? It's not an easy thing that it can easily handle millions of logs. We definitely have to follow some pattern, because on highly scalable application, there are so many things which are hidden until you are publishing or launching the application. I'll explain that one by one, like the hidden things which you will never know without making the application live. You will never realize that it can happen in your application when you're going to live it or after making it live. All right, now let's come back to here. I still didn't finish the ingestion API. So ingestion API means it's basically sending the request to a message broker. Okay, first it's sending request to here, to our AuthGuard, which is basically like a middleware before our API endpoint. The guard is basically validating your API key very quickly and checking your project access and also checking the users limit, which is very important because end of the day, we are still a SaaS. So we have to track your users, and it needs to be within a very short time. Otherwise, we never can process millions of logs within a minute. And for that's why we're using here some caching mechanism. You can see fast validation cache. We're using here local LRU cache and Redis cache. With that caching mechanism, we can almost verify your request within a 0 to 1 milliseconds latency. So we can verify your request within a very, very short time. If the cache is missed, like for non-active application, it can happen. Then we are checking it from PostgreSQL, which is like the source of truth for our data or like the main database. And in that case, we're checking it from our PostgreSQL database and we're refreshing the sync. We're updating our cache again so that second time we can provide the data from to our cache. And definitely in our cache, we need to work with the latency, because inside cache, you cannot store all the data because there is definitely a limitation for storing data into caching mechanism. And that's where most of the beginners do mistake. Some of them, they don't store the important data into caching mechanism. And some of them do the opposite. They store everything inside caching mechanism, and end of the day, the Redis or the LRU cache just crash somehow. And it's a very simple problem, not simple problem. It's a very common mistake, but there are some mechanism which you can follow to get rid of these problems. Now here you can see we also have an alerting engine, which is the most important part of our application, because when there is, let's say, something wrong, that's why you're using our platform, right? When let's say there is 50 weird error from your backend, if there is more than 50 errors from that same thing, then you can set up on logic inside our dashboard that when there is this error for more than 50 times, then send us an alert, and the alert will be basically go with an webhook request. So you can set up a webhook request inside our application. We will send you a post request that something is wrong, please check it out, what's wrong inside our application. We will show you the live logs, which I'm coming after some time. Now here, after the AuthGuard, I explain it how we're going to validating the API key, the project access, and the users limit. Next step is Nats JetStream. Nats JetStream is the message broker. Now, why message broker? Because the amount of logs, that's a lot. We cannot process that within a very short time by using our REST API. It will usually crash. That's why the REST API for ourselves, we are having a REST API, but that's going to act like a message broker producer. So the task for the API endpoint is receive the event. This logs, this info, error, or warning, we're going to count that as events. So we're basically, our API endpoint is going to receive the events after passing the middleware or the guards, and that will forward that event to this Nats JetStream consumer. Now, what is consumer? Consumer means the message broker, which is going to process the event. That's called the consumer or the processing layer. Here you can see we're using Nats JetStream because it's high throughput and durable queue. We can replay the queue. there is a very, very important thing you have to understand. Like most of the people usually don't understand until they're going to the production, and that is called, sorry, I forgot the name. Let me remember the name, just a minute. It's called idempotent problem. Yeah. So idempotent meanings when you are sending a data, let's say we are having every second 1000 requests. Since the request 1000 is not a small number, it can happen sometimes we are processing on event for twice. Definitely that's a bad thing, because let's say your users are getting one error, but somehow our application is processing that for twice. So it's like getting stored at twice, which is a wrong thing. So for solving that problem, we can, like in here, we're in net JetStream, we have like acknowledgement or like the idempotent checking solution, which we can like add and filter, and we can check it that is it already processed or not. And on highly scale, it's very, very critical to like filter it within a very short time, because that's a like big amount of logs, but we will do that. And I'll show you in the video that how can we do that. After that, we're having the log workers, which I was explaining, the consume, process, and batch, but this is a little different. Inside our consumer, we cannot like store the logs every second. Definitely it's going to crash, which is completely normal, because on every second, let's say there are 10,000 requests. We cannot store all of that, because definitely the database throughput, it is not that much high. That's why we're following here on batch insert after a certain time. So the logic is something like this. In this consumer, we're storing our logs for 5 seconds, all the logs, and after every 5 seconds, our log workers is going to store the logs into ClickHouse. Now, what is ClickHouse? Why ClickHouse we're using? We could use here PostgreSQL, MongoDB, and there are so many databases in the world, right? But ClickHouse is different. And the interesting thing is ClickHouse is used by companies like Cloudflare, Netflix, like these type of big companies. They also use ClickHouse under like inside their infrastructure. But why? Because ClickHouse is not like a traditional database. In ClickHouse, people usually store the bulk data or high volume data. That's how they made ClickHouse. Inside ClickHouse, inserting data is very fast. You can insert data very fast, and it made for things like Google Map or Google Analytics or this type of critical thing where you need to store a lot of data. And it's fast ingestion. You can see fast ingestion and powerful queries also. So even though I added here powerful queries, still it's definitely slower than like the traditional database. And that's why we are having here SSE gateway. What's that? I'm explaining after some time. So basically we are using here ClickHouse because it built for storing logs. Now you might be thinking, or you can ask me a question like, then why people going to use 1-minute logs? They could also use ClickHouse for storing their logs. Definitely they can. And big companies, they use it. They use ClickHouse for storing logs. But working with ClickHouse, it's definitely not easy. You have to create schema. You have to understand the ClickHouse mechanism. Then only you can work with it. And most of the earliest stage SaaS, they definitely don't have time for like work with their logging mechanism for, let's say, 1 week. They definitely don't have time like that. That's why they're going to use 1-minute logs, because it's making their lives easier and it's not expensive. End of the day, ClickHouse is not free. You're probably going to think, yeah, it's open source. Yeah, it's open source, but you have to store it somewhere, right? You have to host the database to somewhere. And that's where the money is going to cost, because you have to host this database, let's say, to any server, and ClickHouse always requires a good RAM and good processing power. So you're going to like spend around $30 or $40 every month. But your application is still, let's say, the basic level. You don't need that much computing power. You don't need that. So definitely then you should use 1-minute logs because it's cheaper for you. Yeah, it's actually cheaper for you. For us, then how we are doing it? Because we are doing it on a high volume. That's why our cost is less than yours, because you're just a new early stage SaaS. But for us, we're doing business with this. So that's why our expenses is definitely less than yours. Yeah, that's why we're basically using ClickHouse. Now for ClickHouse, fine, we're using it. Now we need onQuery API to show you the logs. And another important, like the log tails, like what you usually see, like always like coming up the logs. Those are real-time logs. And how then we're doing it? We're storing the logs in here and we're sending that through this SSE gateway. SSE means server side events, I guess. Server send event, not server side events, server send events. It's something similar like the what we say webhooks. No, not webhooks. It's like we use in the messaging app. I really forget this type of things. WebSocket, sorry, I really forgot the word. So we already used WebSocket in so many of our applications, right? In the past tutorial series. But there is difference between WebSocket and SSE. There is a very big difference. WebSocket is made for multiple layer communication. Meaning from the front end, you can send data to the WebSocket server, and from the server, you can again send data to the front end. Like two-way or multiple-way communications, the WebSocket network is going to have. But on the other hand, server send events, it cannot receive data from front end. It's just one-way real-time data. It means from the back end, it's just going to stream the data. It cannot receive anything from the front end. That's the major difference in SSE. Otherwise, almost everything is same, but that's the major difference. That's why when you are storing the data, when we are storing the data in ClickHouse, instantly after that, we're forwarding that same data. Again, we're forwarding, we're not fetching it from ClickHouse. That's why it's real time and zero latency. We are forwarding from here, actually not zero latency, because still end of the day, this is hosted to, let's say, another server, and from that server to the front end application, it's going. So there is still a little latency, but definitely it's not a big number. It's definitely going to be very fast. So we are basically forwarding those logs from these workers to this SSE gateway. That's why our OneMinute logs dashboard is very highly real time. That's why we can make it real time. For the query API, yeah, that time we're basically like querying from a ClickHouse because you're adding some filters into query. That's why. So that's how our OneMinute log dashboard is going to work. So this was the simple system design. As trying my best to add all the points in here. Still, I don't know. Probably I added, let's say 95% or almost all points in here. And I hope you understand everything in this chapter. If you're having any question, feel free to ask me in the comment section. I would love to clear your confusion. So yeah, this was the part. See you in the next one. You probably didn't understand every part of the system design. And honestly, that's completely normal. Building systems like OneMinute logs requires understanding a lot of difficult concepts. Things like caching strategies, distributed systems, message queues, and system design are not hard because the code is complicated. They are hard because it's often difficult to build the right mental model. And that's actually one of the reasons I've been recommending Brilliant for years. I like how they teach difficult concepts through interactive problem solving instead of pure memorization. And recently they introduced something new that caught my attention. It's Brilliant's new tutor. Instead of just watching another tutorial or reading documentation, the tutor sits right alongside you while you are learning. It can see what you are working on, ask guiding questions, draw diagrams, and help you understand concepts step by step. What I like most is that it doesn't just give you answers, it helps you figure things out by yourself. For example, if you're learning algorithms, probability, programming fundamentals, or even system design concepts like the ones we're discussing in this video, it feels much closer to having a personal tutor than simply following a course. If you'd like to try Brilliant's new tutor for yourself, head over to brilliant.org/Becodemy. You'll be able to try it for free for the first month, and you will also get 20% off an annual subscription. That's it. Now let's back to building OneMinute logs. Alright, from this part, we're going to start to coding right now. At first, we have to set up the authentication mechanism. Now, first of all, I want to explain you a few things. Why authentication? Because authentication should be the entry point for our application, and it's another most important thing for our application. It's like it must need to be highly secured. And for the authentication, I'm going to use a third-party platform, and it's called Clerk. Right now, I know you will ask me a lot of questions because in my last video, I saw a lot of comments that why I'm using Clerk, why I'm not making the authentication mechanism by myself. Clerk is like making a vendor lock and so many comments. Now I'm going to answer you all of those questions. First of all, why Clerk? And before answering that, why actually third-party authentication library? Why we're not making it by ourselves? So authentication it's not just a very small or simple thing, like you were just making the authentication. Let's say the social authentication, you're just verifying the token and just letting the user to log in. It's not that much simple. Yeah, if you are making it that much simple, fine, but it's not highly secure. If you want to make a highly secure authentication mechanism, you have to spend a very long time only for making the authentication. And for any SaaS like this, for early stage SaaS, you never should waste time like that for making the authentication layer. Why? Because in that time, you can focus on the other part of your application. And that's why we can use third-party layer or third-party provider, especially for the authentication. Now, there are some questions like when we're using third-party applications, definitely it's not going to be free. Makes sense. But even when you are making it, it's still not free. You are giving your time. And that's where the things actually comes in. Because for SaaS, it's more important how much fast you are launching your product. That's very important. So for the authentication, it's nothing wrong to use on third-party library, especially for the MVP layer or for the first few version. Because later on, definitely you can check it. You can change it back to your authentication internal mechanism, right? You can make it by yourself. But at the first time, you never should do it. You never should waste time for something like this. Now, why Clerk? There are so many options, but Clerk is one of the most famous authentication provider, and I would say not famous, I would say the trustworthy authentication provider. You can see companies like Ingest or even OpenRouter, or as I know, like there are some big, more famous companies, they're using Clerk inside their application, even like companies like Upstash. So the reason is Clerk is easy to set up. Clerk is trustworthy. You can use Clerk easily. You can set up it like within a very short time. And the pricing is not crazy. I mean, when you are starting a SaaS, definitely you're not having a lot of active users. You can see 50,000 active users limit, free. When you are having 50,000 users, it means definitely you're not an early stage SaaS. You're at least earning some money. And then you can change to Pro, or even you can download your data and you can change it. There is another famous, or I would not say famous, there is a very everyone say this, that Clerk or this type of platform, they're going to vendor lock you. But in reality, it's not true like that. If we talk about vendor locking, the same thing we're also doing. OneMinute lock is also doing the same thing. When you're implementing this application inside your infrastructure, you cannot change it within one day because you added this everywhere inside your API, gateway, and everywhere. You cannot change it overnight. Same thing for Clerk. But at the same time, it doesn't mean it's impossible. Definitely, you can download back your data and you can again store that data into your database. You can convert that to the format you want. Everything is possible. Same for OneMinute locks. You can also export data and you can change it to another application. It's possible, but it requires time. And this type of SaaS, we are not targeting, or even OneMinute locks itself, we're not targeting the enterprise applications. The enterprise business, we're not targeting them. They have money, they have engineers, they can do whatever they want. But for the early stage SaaS, definitely they don't have the money or that so many team members. So they should focus more on speeding the application or speeding up the service. Like for 1 minute logs, what we're doing, we're not just like saying that, hey, you can store log by using our application. There are so many applications like that, like Datadog, Sentry. They're also doing the same thing. We're saying you can set up it under a minute. And that's what we're selling. Our selling point is ease of uses. Same for Clerk. They're also doing the same thing. So when you were like setting up authentication under a minute, definitely you have to sacrifice few things, same like in 1 minute logs. So that was about Clerk confusion. If you still have any confusion, let me know in the comment section. I'd love to share it with you. But don't say it like that, why I'm using Clerk again and again, because it's easy to use, and for the MVP version, it actually makes sense. Now, for going to Clerk, you should go to the link you're currently watching on the screen, or you can also go to 1minute.run/clerk logs like this, and it will redirect you to the appropriate page where you have to right now go. From here, you can create an account if you're for the first time, and if you have an account, then you can hit sign in and do the login from here. And here you go. After doing login or creating your account for the first time, you can click this create application. Or if you're for the first time, it will not take you here. It will ask you for creating an application, something like this. And for your application name, we can say 1minute logs. And for the authentication, we can set up email and Google. And that's all. That's good for us. We don't need anything else. Organization, we can create it. Like sometimes we probably need this since we're making logging mechanism application, we should add. For the billing, we can definitely add, you can add some subscription in here, and it's easy to work with Clerk, with the subscription. So we can add it, and you can see define and manage plans and subscription in Clerk. No additional fees required. So you don't have to pay any extra additional fees. It's just like you're using Stripe. It's kind of same, but it's more easy to set up. So we can definitely use the billing from here. And we can click this create application button from here. After that, it's going to create our application. This is we're inside development mode, and it's giving us an installation prompt for our AI, but we don't need to use AI. Yeah, because I'm not going to use AI for this because it's very easy to set up and I know how to do it. So I'm just showing you what to do. Just copy this command, come back to our project again, open a new terminal. We have to go to our apps and the landing page. Here, let's install Clerk Next.js, this library. And after this, we have to copy this. Let's come back here again. And in our .env, in landing page.env, you can see we're already having on Clerk publishable key and Clerk secret key. Yeah. We chose definitely the older one. We need the new one. All right, all ready. Now, what we have to do, we have to come back here again. This is ready. We don't need any Clerk middleware for now. So we can come back here. We just need to import the Clerk provider and show sign-in button and everything, but we don't need that. So let's copy the suggestion and let's come back here. Let's import it. Sorry, I already set up Clerk in here. Oh yeah, so there is already Clerk provider in here because I was setting up it for the waitlist. That's where you can see Clerk provider, and I'm even passing the UI in here from Clerk UI library. Make sure that you're installing this library, Clerk UI library, and probably you don't have to do it because you're already having this library in your code base when you are cloning the starter project. Now, after this, let's create our sign in page. So sign in and something like this. So sign in. Actually, I think we can add any endpoint in here. Yeah, that makes sense. So sign in and something like this. You might be thinking how the waitlist in here, because this is already Clark setup waitlist for the production one. But right now, since we're making it, we don't need the waitlist anymore. So let's make the real like logged in authentication page. So we can copy this waitlist code. We can come back here. We can paste everything. Instead of waitlist, we're gonna import here sign in, and we don't need this. And here we need sign up URL, I guess, sign up URL, which is going to be sign up. That's it. We can save it. We can come back here. We don't need to do anything in here. Let's come back here and go to /sign in. And here you go. You can see our sign in form is ready. Yeah, that's how easy we can set up authentication. You can see continue sign in to OneMinute logs or application name. And it's like the sign in page. We can hit sign up. It will take us to the sign up. Let's come back here. Let's copy everything. I think we should copy this folder, this app. Let's paste it again and let's rename this to sign up. Yeah, and inside here, same, just rename to sign up. And inside here, instead of sign in, do it sign up, and sign in URL, which is going to be sign in. Simple. Just save everything and let's come back here, give one reload, hit sign up, and here you go. Create your account. Everything is in here and everything makes sense. You can just add your email address and password and you can create an account, or even you can continue with Google. So after doing the authentication, actually our authentication is ready. That's how you can set up authentication. But in here, let's do one thing. Let's do login. So we have to change the code a little bit now. Let's come back here. We don't need the waitlist anymore. So we can basically, we can uncomment this. We don't need this actually, the one click. Is we're having here for the login, we're going to redirect to sign in. For the get started, sign up. That's it. Now in the drop down, we can definitely uncomment it. And here we were saying something, but let's do one thing. Let's cut it. Let's come back here. This is already use client. Okay, so we can use here our use user hook from Clerk Next.js. And this is our user and is loading. So is loaded and it's signed in. We need all of this. When the is loaded is true, then everything fine. But if it's false, then return null. Yeah. Then user, here we can say, just a minute, where is the header? Sorry, the drop down. No, we shouldn't delete. So did you delete something? Wait, let me press Command C. Where's the header? Yeah, somehow I deleted. So we don't need to delete. We make sure that we're not deleting. And then again, we can add that in here, use user. Now let's come back here. Let's cut this and let's say that if our user is available, or we don't need that, let's say is signed in true, then this one, otherwise this link. So let's cut this, add it in a fragment, and let's paste it in here. We can save it. Now you can see it's showing login and get started because we're not logged in yet. So let's hit continue with Google. and I'm doing on Google login. And it's asking us for an organization, which is definitely very good, because in the future it can happen that in OneMinute logs we will support multiple projects. That's why for that type of thing you must have to set up an organization. So we're adding that feature from right now, so that in the future we don't need to worry about like changing our mechanism internally. So we can hit continue, and here we go. It's showing the GitHub logo. Fine, because we are adding here like a static value, that's why. But here we can say when there is user data, then user dot profile, or I forgot the value, so I think has no user dot avatar, set profile image. Just a minute, there's so many parameters here. Okay, fine, let's do one thing for now. Let's go back, and since I forgot it, let me do one thing. Let me console log the user. Let's come back here. We don't need to go anywhere, you can see it in here. So for the avatar, it's in here, image URL. Okay, so is it in any array? Yeah, external accounts, and this is the image URL. Okay, so image URL, no, it's already in here, user and image URL. Okay, makes sense. So if there is user, then user image URL, or something with is user, then user dot image URL, otherwise empty. Yeah, so the clerk, we have to set up this host name in our Next.js app config, sorry, Next.js config. Here, let's set it up. We can say protocol HTTPS and host name, something like this. We can save it. We can save it here as well. Let's come back here now, and here we go. Everything makes sense. This is for dashboard, this is for billing, this is for settings, and this is for support and for logout. Let's make the logout dynamic as well. So for the logout, if anyone press here or one click, it's going to call the logout, or I think sign out. Okay, 1 minute. Logout handler, it's the best option. So we're going to call on function logout handler, which is going to do the logout for us. We can say await, and then we can add here async sign out. Okay, I forgot the syntax, so let's search sign out button, or no sign out button. All right, I just remember it. We can basically use here on hook like this, that use clerk, and we can use the sign out from here, and then we can call that in here. Right now, if you come back here, and let's say come back here, give on reload, just click here and hit logout, and here you go. We're logged out right now. We can again do login and do the logout. So the authentication is ready. Yeah, that's how simple it is. Right now, our next task is we have to start to work in dashboard. We'll start to work with the API key right now, like the verifying the API key, verifying the access, and also at the same time, like we have to make the guard in our backend. First, we're going to set up the front end. I mean, the front end is already ready. You can already check it out in the GitHub repo. You already have code for the main dashboard. We're going to just modify it, and we're going to start the main backend work right now. So let's get started. All right, welcome back to a new part. Right now, we'll start to work with our backend. So we can clear everything and you have to go to the services. However, since I restarted the VS Code, that's why I have to actually go to the landing page like this. Let's open another terminal and go to our main dashboard. Now the next one is basically our services. Yeah, we can clear everything and you can see in services it's completely empty. No problem. We're right now going to create a Nest.js project. So for creating Nest.js project, I have to check it. Nest.js. What's the like command? I forget it. No problem. We can say first step. We don't need this. Sorry, not first step. Getting started. Yeah. Wait. Getting started. I didn't say course. Okay, fine, no problem. So first of all, you have to install the Nest.js CLI. But for me, for my laptop, I do have Nest.js CLI, so I don't need to do anything. I will just come here and say nest new and a dot, so that it will create the project inside the services. npm, I'm selecting as the package manager. It's right now creating everything. You can see, yeah, everything is in here. One thing I just want to have, I just want to quit the MongoDB. I don't need to turn that one. Yeah, already we can hit clear. I mean, we can write clear. So you can see in here, node modules and everything is in here. However, it's definitely like the boilerplate code base. We have to do a lot of work in here. We will do one by one. If we come back here, and this is our main like TS, what it's saying, like, okay, fine, ignore these. It's probably giving us on a warning that add void operator to ignore it. Okay, fine, no problem. The TS config base URL is deprecated. Okay, so the boilerplate code base is giving error, which is definitely a funny thing, but no problem. Base URL is deprecated. Seriously, I didn't know it earlier. However, if I change it, I mean, if we remove the void, is it same error? Yeah, so it definitely not connected with each other. Okay, base URL is right now deprecated and will stop functioning in TypeScript 7.0. Please specify compiler options. So what we're right now then we're supposed to do in here, let's go to here in this documentation, because this base URL is not something small, it's important thing. Let's see what's wrong. So migration issue here, base URL was recorded in order to use paths. Yeah, this is no longer the case in many projects. You can simply remove base URL, especially if it's like the root directory .means, otherwise depend base URL. Value to each paths entry. Okay, fine, then I think we should remove it, no problem. Yeah, we can come back here. We have to change the port. We will do that. Let's create on .env at first in our services. .env and port, we're gonna make it 8080. And the fallback should be also same, 8080. Okay, app module, service, everything looks good. In the services, let's add a new folder by giving them modules. Inside these modules, we will have all of our modules. However, the module should be inside the src folder, not outside. Yep. And we also need our configs, then controllers. Okay, fine. And we can add another folder for guards, then infra for like Docker related things, Docker or JetStream or ClickHouse, and database for setting up the database. Yeah, that's all I guess we should have. Yeah, for now it's good enough. Now in this configs, it's basically like the variables throughout this all like the full project. So you can add just on index.ts here. For database, fine, everything should be empty for now, no problem at all. In the modules, let's start our first module, which is API keys, or actually for the API keys, there should not be any modules. Now you might be thinking then how the thing will work, right? Yeah, so the thing will work because in here, or wait, I think we should create a module. Yeah, we should create, because in the last project we didn't do it. But for this one, let's create a new module by giving them API key. Inside here, we can add our API key dot controller dot ts, API key dot service dot ts, and finally, wait, all is going to be inside here. This is not folder, it should be file. Let's delete the folder and make it a file. Yeah, now we need our API key module. Yeah, and inside modules, let's create another modules. Let's say something like, we can say that billing. Yeah, for billing we'll have definitely different modules. Yeah, so for now this is fine. Let's come back here in API key controller, and inside guards we are gonna make our like authentication guard. So we can say auth.guard.ts. For database, we have to set up database, so we should do it right now because our API key mechanism and everything, it highly depends on, like, it's connected with the database, so we should set up the database right now. And for this project, we're going to use PostgreSQL. Now we can set up PostgreSQL locally, but that's like added some complexity. And secondly, like, you have to like make sure that the database is always up to date, and it has like, you are hosting it somewhere close to the like your user server. So for the version 1, we should avoid it. We should use third-party services like Neon or Supabase, but for this project we're going to use Neon. Now let's hit login, and from here I'm creating a new project. I'm giving it name to, let's say, 1minute logs, and I'm hitting create. Here we go. We're having our connection string here. I'm just copying the snippet and I'm coming back to our .env. I just want to show you one thing. So you're probably watching it blur right now because I'll definitely make it blur for the security reason. I don't want to expose the database value. So here I'm creating on variable by giving them database URI, like on env variable, or sorry, database URL, not I, then on equals to, and then the PostgreSQL value. So when you're copying that, make sure that you are removing this PSQL, okay? Just keep this, okay? Do not add all of this at the value as like the database URL value. That's it. And you don't need any first single quotation. You don't need any single quotation or double quotation. Just add the value. That's the best practice. Yeah, so database URL is ready right now. We have to install Drizzle. Why Drizzle? Because we're actually using Drizzle as our ORM for connecting Neon. So for Drizzle, you have to come back here and let's search for it, because to be honest, I usually forget a lot of things, which not only me, every engineers, we forget things. We're like definitely are not remembering everything. So how can we set up Drizzle? Just come here and read the documentation. You can hit Neon and Drizzle from here. This is the command. So let's copy this, come back here and paste it. This is the like setting up code base. So let's copy and come back here into our database. There should be a database module, actually database.module.ts. And let's do one thing for here. It's basically going to be a global module, so use the global decorator from Nest.js common and module decorator because it's a module. Here for the providers, we're gonna provide the Drizzle Drizzle, yes, spelling is correct, Drizzle DB. Now what is Drizzle DB? It's basically a like variable, something like this. Then let's use the use factor method. It's like a callback function, and inside here we're gonna add our connection string, the database connection string, which is going to be process.env.database URL. If there is no connection string, then we can throw an error that database URL is not set yet. You have to set it. Otherwise, here we can add const pool, not peel. It should be pool new pool from neon database serverless, and let's pass the connection string in here. However, I did a small mistake. Let's add it in here. Yeah, and after this we can return Drizzle from our Drizzle, basically from our PostgreSQL. 1 minute. So where's that? Yeah, neon serverless. I guess we can import it from neon serverless. Yeah, and here we have to pass the pool and schema. Yeah, now schema is basically coming from here. Let's create our schema.ts and import everything as schema from /schema. Yeah, now after this we can add the exports, and we can export the Drizzle DB, and we have to export our class, the database module class. Yeah, that's it. This is giving some weird warnings. The reason is simple, just delete the istlin. I really don't want it. Yeah, all looks good right now. We don't need this one because this setup was basically for like Express.js or basic like Node.js. But here, since we're using Nest.js, our setup is a little bit different. So that's why we basically made this database module, like a global module, so that we can use it anywhere we want. That's why our setup is a little bit different. Yeah, fine. Create a table, all good, but we need this drizzle config.ts file, the most important file. Let's come back here in our services folder, and let's add the drizzle.config.ts file. So in this drizzle.config.ts file, we have to paste everything. However, in here, .env, I think we should add it like this: import everything as .env from .env. Again, we are using Nest.js, so the setup is a little bit different here, and we have to call this .env.config. Now schema is going to be, at first add the schema, which is going to be source, then inside source, what's the folder name? Database. So database and schema.ts. Yeah, and out /drizzle, it's fine. Dialect PostgreSQL, very good. And credentials, database URL, all looks good. It's fine actually. We can save it. After this, we don't need anything. This is perfect. Yeah. Now what we have to do, we can come back to our schema, the like schema.ts, and inside here we can create our first like table, which is going to be for our API key. So we can say const API key pg table API underscore key and ID, something like this, UUID from our Drizzle ORM and PostgreSQL core. We will have an user ID, which is going to be like text and cannot be null. Import text from SEM, like the PostgreSQL core. We should keep it in same import. Yeah. After this, we need prefix, like on short value. Then value, the value for the API key, which is definitely going to be a hashed value. Now created at, like when the API key basically created, the date, and last used at, very, very important one. Then revoked at, if you were revoking the API key. Yeah, that's all we need. For now, that's all we need. If you need to change anything, we'll definitely do that. But yeah, let's come back here now. Let's clear everything, and we have to set a few things in our package.json in the scripts. So let's add few new scripts here, like db generate. We can say npx drizzle kit and generate. Then db migrate for the migration. We can basically copy this. Instead of generate, it should be right now migrate. We can again copy this, and this time this is for pushing. So npx drizzle db push. We can save this now. npm run db generate. Great. npm run db migrate. Yeah, and npm run db push, very, very important. Now after this, if we come back here and in these tables, here we go. I think we're having the API keys. Yeah, here you go. You can see the API key table is in here. So if it's coming like same exactly like this for you, then congratulations, our database setup is done. Right now you can start to work for the API key feature since the database setup is done. I'm mistakenly deleted, but we have to come back here. Yeah. So let's close the package.json schema database module, and in this API key service, we're gonna start to work now. First, in this API key module, let's finish this. It's going to be very, very basic, like a normal module. We can come back in our this app module and we can copy everything and we can paste it. Now for the controller, it's going to be API key controller, but we're not having it. Same for the service, we're not having it. So let's delete it. Let's delete it and make it API key module. Yeah, fine. Now controller, at first we need to make service, then we can make the controller. Okay, now let's start the API key service. All right, at first we can add here on injectable decorator. After this, we can export, or you can create our API key service class. And inside here, let's add our constructor and let's inject the Drizzle DB. So inject from this just common our Drizzle DB. Let's give it a name, that private read only DB, and type we can make it any. Now we have to add Redis. Now why do we actually need Redis? We need Redis because for API key service, especially for things like the last usage time and this type of everything, we must need to have Redis. And not only for that, I already explained it in the system design that why we're actually using Redis for our API keys, because of validation, because of like faster query, and for handling a large scale of request within a very short time, we're using Redis. Right now we have to set up Redis. So let's set up it, and not only Redis, we're right now going to set up our caching mechanism. It's very simple. Setting up is not hard. In this infra folder, let's add our cache module.ts and the Redis module.ts, these two things. First, for the cache, let's add here first on variable that LRU cache, like on export const LRU cache variable, which values LRU cache. On interface for our caching, that the caching will have on user ID, public ID, and last used. Now we can use here on global decorator because this is a global module, and the module decorator, then providers. We can provide the LRU cache from here. We can use here use factory and return the new LRU cache, actually LRU cache. Now LRU cache is coming from our LRU cache library, which we haven't installed, I think so, or we have to install the type. So let's come back here and let's install the LRU cache types. However, it's giving error because the spelling is wrong. I don't know, still it's giving that warning. I don't know, I think this is on built-in module. Still, let me install. If it's not, then that can cause some error. Yeah, it was not. So right now it's not giving no warning. So everything is fine now. Now here, LRU cache, we're importing it from, basically we're importing it from our LRU cache. So yeah, it's already in here. Sorry, we already imported it. String is not big capital, string, and the cache interface. This is the type. Now we have to set here some values that maximum cannot be more than 10,000 entries. The TTL, which is going to be 5 minutes. So 560 multiply 1000. This is like the default value. Update agents on get, make it true. Update agent on has, make it false. And allow stale, make it false as well. From here, we can export the LRU cache. Yeah, and here we can export the cache module. Perfect. So we can save it right now. We can come back to our Redis module and we can start to work with the Redis module as well. So sorry, in Redis module, at first we can copy the cache module. Then we don't need to write a lot of things again and again. Instead of LRU cache, this is right now going to be Redis client. And for like interface, we don't need anything for the Redis client interface because it's going to be simple and small. But we have to install a new library called IO-Redis. So we can say npm IO-Redis. Yeah, done. And import Redis from IO-Redis. We don't need LRU cache. And we need the global and module. For the providers, provide is going to be this time Redis client. And here, let's add our config service because we need the Redis like value. So config service is basically coming from our nestjs/config. I don't know why it's not giving suggestion. Okay, so we have to install it. That's why. Let's install the nestjs/config library. Yeah, done. Redis is going to be like this. So config service ready. Now in here, let's remove this. And let's add const Redis, new Redis, new Redis. The host is going to be the config service dot gate and Redis host. Value is going to be local host by default. The port is going to be SIM. We're getting it from our .env. Password SIM, and here let's delete. And after password, we also need the DB, the Redis DB, or by default 0. And retry strategy for like connecting Redis. If the time's more than 3, then return null. Otherwise, math.mini, like after certain time, we're pulling it so that if like the Redis value is not available or it's not warmed up yet, then we can like add here retry strategy. So it will start the Redis database somehow if the value is available. Then after this, we can add redis.one. We can connect our Redis right now. So connect, and we can add a console log that Redis connected. Yeah, and if it catch any error, we can basically console log the error message. Yeah, and finally we can return Redis. Yeah, and we can inject, actually we have to inject our config service, otherwise this will give error. And we have to export our Redis client, and we have to change this name from cache module to our Redis module. Yeah, all done, but one thing is not done, and that is setting up Redis. So as I said earlier, we're going to use Docker Compose for setting up Redis. Right now you can tell me we could use Obstash. Yeah, we definitely could use Obstash for setting up Redis, but still when you're using Redis in our one machine, there are definitely some pros and cons. Like the pros are definitely it's going to be like highly scalable or more faster than Upstash one, because that's on a different server. And when you're setting up Redis into the same server by using Docker, it's going to be more fast because it's already in the same machine. So for the version 1, we can use it in our own machine. But when in the future we're having probably multiple server, then using it in the same machine, it's going to be a problem. That time we can definitely like use another service, or we can like host Redis to another different machine, and we can like make that for our project. But definitely for the version 1, for right now, for the MVP, we can set up Redis in our local server. Yeah, so we can say services Redis. We're gonna use here our Redis 7 Alpine image, container name, we can say 1minute logs and Redis. Environment, we have to pass our Redis password. So environment and Redis underscore password. Let's set the value in here right now for like, for at this moment, I mean, for development mode, we can set the value in here, but for the production, we'll inject the value. We'll not push it like this because this is risky. So for the Redis password, we can say something like this, that 1minute logs for now. After this, we need our ports. So for the ports, we can use 6379 and 6379 port. Now volumes, Redis underscore data slash data, something like this. Now for comment, like for setting up this, we can say Redis server and user require pass flag. The password is 1minute logs, and use append only flag again. Append only And another flag, that maximum or max memory policy. These are very important. And all keys LRU. Yeah, so it's quite big, but this is like the comments. After these, restart unless stopped, and health check. C cannot be capital actually. We're in Docker Compose. Now test. For testing, the command like Redis CLI and the Redis password. Actually I did a small mistake. Yeah, here it's going to be 1minute logs. Yeah, and for testing we can add that ping pong. So ping, sorry, then interval. Let's add an interval, 10 seconds, timeout 5 seconds, and retries for connection 5. Yeah, that's it. Our Redis setup is ready. Now we can add on volumes. So volumes, Redis data. Yeah, we can set up it. The volumes, I think we have to keep it here. Yeah, so our Docker Compose is ready. We can right now come back here and we make sure that you are having Docker in your device. So for me, I do have Docker. I'm just opening it. Here you go. Now we can say Docker compose app and -d, and we have to allow the network access. It's basically pulling the image. However, oh, I added a wrong spelling, Alpine. Yeah, Alpine. That's why it gave error, which completely makes sense. Now recreate it and start it. If you come back here, if you give on reload, it's actually working because there is already on Redis image already there. So it's basically restarted, and for you it should work right now. Now everything's set up done. Just one thing is not done, that is we have to add our Redis like host, port, password, and a DB value. Yeah, something like this. Okay, so I'm showing this to here to you so that you can just add it in the .env, because I'll not show you the .env value which I am adding right now. So just a minute. .env I cannot show you, that's why I'm taking it to another screen. Yeah, I should not show .env in the video. All good. Now let me clear everything from here, and our Redis module is ready. Everything is ready. Now let's come back to our API key service again and let's finish it. After the Drizzle DB injecting, here we can give a comma and we can say inject our Redis client and private read only Redis. Yeah, now after this, inside here we can add our first private module, that create API key. This is not private module, we're gonna use it inside our controller also, but yeah, for creating the API key, this is the module. It's going to receive user ID, because for creating an API key you must have to be a user, and we're receiving that as a parameter in here. Now we are forcing our user to create 5 limits, right? Like the highest limit for one user is 5. One user cannot create more than 5 API keys. If you're creating more than 5 API keys, you have to contact like support. to get approval, which is very, very important to like prevent our applications or protect our applications from spamming. So here we can say this .db.select and count. Let's import count from Drizzle ORM, and from our API key table where the API key.user ID is matching with our user ID. Yeah. Now, if the result is, or not result, the result count is like less equals to than 5, if it's 5 or more than, like less than 5, sorry, more than 5, then we have to throw an error in here that you have reached the maximum limit of 5 API keys. Please contact support for more. And bad request exceptions from next is common. Now we have to generate an API key. So for our API keys, we're basically following on strategy. Our API keys is going to be something like this, that OMC, then OMC means 1 minute, not OMC, basically 1 minute log. So OML, and after this underscore, and there is going to be on public ID, like on UUID, it can be on UUID, and then later on the last part is going to be on secret key. Now, why this structure we are following? We are following this structure because after creating the API key, we are not storing it inside our database. So since we're not storing it inside our database, we are storing the hashed version. And when the user is like giving the API key to us, when like during the verification or the validation, we have to again like hash that API keys which user is giving us, and we have to compare it. Compare from where? From our database. So definitely it's not a small thing. It will take a long time. And in our application, since we're having a lot of users, since we're planning like that, that's why we cannot make it this way. And to prevent this problem, to solve this problem, I basically designed it in this way. So here there is on UUID. So first one is called flag. This OML is the flag, like the unique flag for 1 minute logs. UUID, this part is the public ID. Now the interesting part is this public ID and our API keys public ID. Here, this ID completely same, but this secret key is not same. So if you're probably thinking, okay, since this is public value, this UUID, it's not public, but we have this value in here. So since we're having the UUID in our database, we can verify it very fast and we can store it into the cache. We cannot do that same thing for like hashing value, because for hashing on like on API key, it takes time. It's slower than verifying from cache. That's why we're doing this UUID verifications, so that we can speed up the process. And with this strategy, we can like speed up this verification process more than 3 times fast. Yeah, so that's why we're basically following this strategy. Now let's do it. Let's do the coding which I was explaining you. So here we're gonna add a new private module for this, like the generate key, which is going to generate the key with that strategy which I was explaining you. So generate key, it's going to return the plain text key, like the raw value string, and the key ID, like the public UUID. Now for the key ID, we're gonna use here crypto.random UUID and then .replace. Let's use here an regex pattern like this. Yeah, so basically it's removing all the hyphens if I'm not wrong. And then secret, the most important part. So this one is going to be completely different, like random bytes. Just add on 32 bytes random like secret, and let's make it base64 URL so that we can like make it more secure. Now the plain text key, or the main key, which is going to be something like this: OML underscore our key ID underscore the secret. So secret. Yeah, so this is the API key value, and we can return the plain text key and the key ID. Yeah, now let's receive it in here. So we're receiving the plain text key and the key ID in here. Now we have to hash it because we cannot store this plain text key into our database. We can say await, and for hashing we're going to use Argon2, the most secure on, or the industry standard right now. We can use Argon2. So let's install npm I Argon2, and we can say Argon2. Let's import Argon2 from Argon2 and Argon2.hash. We have to pass the plain text key, and the type of the hashing is going to be Argon2.Argon2ID. So Argon2 ID, not 2D, 2 ID. Time cost is going to be 3. Sorry, 3, not 2. Then memory cost is going to be 1 and something like this, 16. And parallelism is going to be 1. Yeah, that's it. Now let's make a prefix for showing to our database, like on value, like the first 18 characters from the API key to show the database, sorry, to show into the like in our client side, in the front end side. Yeah, the prefix is ready, and after that, like the dot dot dot, like the ellipses. Now we can store it. So we can say this dot db dot insert. We can insert into API key. The values are going to be, ID value is going to be the key ID. User ID is going to be user ID, user underscore ID actually. Then value, it's going to be the hash value. And prefix, the prefix. Yeah, and finally we can return the key to the front end for once, so that the user can like copy it and save it somewhere safe. Now next module, let's add all it right now, so that we don't need to come back again in here. Now this is for listing all the API keys the user is having. It's very easy, just some queries. So we can just run on query. We can say this dot db dot select and ID. We need the API key ID, the ID value. We need the prefix, which is going to be the API key prefix created at the API key dot created at last used at, very, very important. We can say API key dot last used at and revoked at API underscore key dot revoked at. Now dot from API key, from the API key table. Yeah, where the 1 minute, where we have to use here and operators, and from Drizzle ORM, the API key dot user ID is matching with the user ID. Yeah, something like this. We can save it. Now next one is for deleting our API key. So we can say delete API key, it's going to also receive the user ID and the key ID. Now for deleting, we are basically doing this await this dot db dot update, because we're not logically deleting the API key, we're updating it. We're saying API key and we're setting that revoked at the API key is basically revoked now. So revoked at new date, yeah, where our user ID, sorry, API key user ID is matching with the logged in user ID. Yeah. And next step, very, very important. After deleting an API key, we must have to delete it from our caching mechanism also. So we can say this dot redis dot delete, and wait, I am outside, but I should be inside. Yeah. So this dot redis dot delete, here we're gonna say oml API underscore key, then the version. So version is like on version management system we're going to use. So for the version, let's add on global variable here so that in the future we can easily change it. Yeah, version. And this is important for like versioning it in the future. Like when you are adding the version 2, you can easily revalidate the caching easily. After version, we can add here our key ID. Yeah. So now I know you're right now going to ask me, we haven't added the Redis key. We're deleting it. Yeah, we didn't do it. We will do inside the guard, but since we haven't made the guard yet, that's why we don't have the Redis like key right now yet. This is like we're doing it before even creating the Redis key. But fine, in the future, in the guard, we'll definitely add these OML API keys for like when only user is like trying to or using an API key, then we will definitely add that. But after deleting the API key, we have to instantly remove it from the cache. That's why we're deleting it from the cache so that it doesn't conflict in there. And we also have to delete it from local cache. Now local cache is on variable, something like this, on new LRU cache. We can say LRU cache, and cached key, this is giving error because we can set it up actually inside our this config index.ts, something like this. Definitely it's the same from our this caching module. It's the same thing. No, it's not same, it's different. See, user ID, API key, digest and expires at. In here, this was different. User ID, public ID and last used. Yeah. So just add this new type in here, and then in here we can import and we can save it. Our delete API key is also ready. The next one is the regenerate API key. Sorry, not ready. We have to delete. I forgot it. Delete the version and the key ID. Async regenerate API key, user ID, which is going to be string, and key ID, which is also a string. And here for regenerating API key, we have to do few things, not one thing. First, we have to regenerate a new key like this, like what we did for creating an API key, the same thing we're doing here. And this time the key ID is a new key ID because it's for like new one. Then we have to hash it again as like always. Then we have to make the prefix. It's basically like we're creating the API key again, and we are updating our database instead of creating right now. You can see this .db.update API key value is this one, prefix this one, and created at new time, and we are updating it instead of creating, instead of insert. Yeah, this time it's update. And we also have to update our Redis key or the local cache LRU key. We have to delete it because this is a new one, new API key. That's why. And we have to return the plain text key. Now after this, the most important, that is our API key last use time. So last used, this is a very critical thing. Why I'm saying it's critical? Because API key last use, it's like a very frequently changing value, and we cannot like fetch this type of things for a long time. We never can do that. So that's why we are actually sending this data from our caching mechanism. From our caching mechanism meanings from Redis, we're fetching it so that it doesn't have any problem like when someone is like asking for it. But otherwise for database query, it's definitely going to be slower and frequently we cannot do it. And database value is also not going to be always up to date. Like every second when our applications, they're using our application, when application using our application, yeah, means our client or our users, they are using our SDK inside the application. Every time we cannot update the last use from the database. We can update Redis, and after a certain time, let's say after 30 seconds or 1 minute, then we can only update the database with on like batch update, which I was explaining in that system design. The same thing we'll do it in here. So that's why, since the Redis one is real time, we will forward or fetch the data from Redis and we'll forward it to the front end. So here we can say redis.redis.hget, the last used hash. So here we're going to use a variable so that we can use it everywhere without having any problem. Because let's say I'm using here a value in the guard, it can happen that mistakenly I added a spelling mistake. Then that's going to be a disaster, because for this type of variable, if you're doing any mistake, it will definitely not work. Now here let's come back. Our last used hash, which is going to be OML API underscore key last used and the version. Yeah, we can save it. We can come back here. We can import it and we can add the normalized key in here, like the regex for normalizing the key. Then if there is Redis value, then we're going to return it. The simple option, like most of the case, it will happen that there is the last used at inside our Redis and we're forwarding it to the front end. Then this is going to be very real time and very fast. Second option, if it's not in Redis, then it means we have to fetch it from the database. This is the slowest one. So we are basically fetching it from our database, the last used add, and then we're returning it from here. Yeah, that's all. Our API key service is actually ready. Now we can come back to our API key controller and we can add all of these route on by one. So API key controller, let's come back here. Let's add our controller decorator, and here we can say API keys and use guards. For now we don't have any guards, so let's don't add it. We don't need to add it. But API bearer auth, which is coming from Swagger. Okay, fine, we don't need to even add Swagger for now. We don't need that. Just add our class name, that API key controller, and let's add our API key service, the constructor, import it. Now post endpoint, the first one is going to be, this is for creating on API key. So we can add here on async create API key. It's going to receive request, which type is going to be any, and then gate for basically getting the all or list the all API keys, then gate and here async list API keys. Yeah, the next one for like API key last used. So this is going to be something like this: API keys slash the ID for the API keys, and we can say API key last used. The ID basically we're going to receive from param, and param is from Nest.js common. Now delete for deleting on API key. Same, we're also receiving here the ID from param. So we can add async delete API key, and we can return the API key service and delete API key. Now for regenerating another API key, something like this, it's kind of like the same, but we are having here on param. However, regenerate API key is giving error. Seriously, why? It should not give error. Regenerate API, oh, spelling mistake, regenerate API key, yeah. Now we can save it and everything is actually ready. Let's close it, this one as well. Now in this imports in our API key module, or actually we have to add our here in the imports our API key module. Sorry, not here. We don't need imports here. Basically, we need the controllers, which is going to be API key controller and provider API key module. I mean service, not module. Yeah, we can save it. We can come back to our app module, and in here in this imports, we can right now add the config module at first, the most important one, config module dot for root, and make it global. So it's global, make it true. And now we can import our API key module. We can save it. We can run our server. We can say npm run start dev. Here you go. It's giving some error. What it's saying: invalid or unexpected token. Where? Alright, so I fixed the problem. It was definitely not any coding issue at all. It was just like caching problem. Caching problem means not our project caching problem. Next.js caching problem. Just delete this dist folder, delete like the .nest folder and clear everything. And then again write this npm run start dev. And this time you will see something different, a new error. And the error is saying that Drizzle DB provider and everything like API key module, you cannot use it like that, which actually makes sense. After API key module, let's add here our other modules. For an example, the database module. Let's import the database module, the caching mechanism or the cache module, Redis module, and then we can save it. Now here you go. You can see it's actually working. There's no error right now. Redis connected, everything is perfectly working. So it's really interesting and everything is working. So our backend is ready. Right now we can start to work for the front end and we can make our API keys dynamic in front end. So let's come back to our main dashboard, app and API keys, and in this page.tsx, let's come back here. When we're clicking this generate API key, the form is different. Here we are having scope, expiry, but for the version 1, we're not going to have all of this. So we have to modify this form a little bit, and we're going to do it right now. First of all, in here, actually one thing is very important. When we're hitting this generate new API key, we should not like add fields like this, like key name, scope, or expiry. We can completely delete it. We should make it as simple as possible for the version 1. So we can do one thing. We can completely delete this generate new API key model. Yeah, we don't need. We need this one-time secret reveal dialog. We need this one, but we don't need. Let's come back here. We don't need this generate open, set generate open, reveal open. That's fine. New name, new scope. We don't need anything like that. We can come back here. We can delete these, the inputs also. For creating key, we don't need to send any of these. So let's delete. Just refresh the keys. That's it. Yeah, and from here, generate new key. Okay, we will change it later. One thing, let me see. This is the last error. Okay, so this is the only one. Now for generating the API key, for generating new key, here we're going to call this create key function. So let's call the create key function. Inside here, it's going to send a post request to our /API/v1. However, why await fetch? So we don't need to do it. We need to make it Axios. Actually, fetch is also fine, no problem, but here is something different we have to do. We have to add here our process.env.next public server URI server URI /API keys, we can say. For the headers, this is the important part. In headers, the content type application JSON fine, but we have to pass our authorization token. So authorization and bearer token. Yeah, so token is basically coming from our clerk hook. Here we can say const token equals to await get token from clerk next.js, and we can pass the token inside here. We don't need to send anything to the body because this token itself is like doing the authentication for us. And then we'll have the response. Inside the response, we will have our key. Yeah, but still let me check one thing from the backend. So source and modules and API key service. So we are basically returning the key. Yeah, we're receiving that in here. Yeah, everything makes sense. Now, let me check again the endpoint. This is /API keys. Yep. Now let's add it in our .env, in our main dashboard.env. Next public server URI. It's going to be HTTP localhost 8080/API/v1. Okay, /API/v1, no slash after v1. They make sure that you are doing it. If you're doing any small mistake, it's not going to work. Something like this. Yeah. Now, after this here, everything is going to work. Just a revoked selected. This is not okay. Otherwise, let me see. For fetching the API keys, this is wrong. Let's delete all of these. And we can use here our use query, so that we don't need to write a lot of code. We can say API keys and is loading use query. So use query is coming from our 10-stack React query, which we are using. But we have to install it. So let's come back into main dashboard, stop the server, copy this, write npm I 10-stack React query. I think we have to add this then in like the provider. Here we go. In provider, we have to add our query provider, something like this. So query provider, 10-stack React query. Query provider is basically not that query client provider, because all right, let's do one thing. Since we have to add some like parameters, so we should create here another folder by giving them providers, and we can add our query provider.ts in here, and we can add our export default function. Query provider is going to receive children, which type is going to be the React and React node. Now inside here we can say const something from useState hook. So useState from React is going to be a callback, that new query client from 10-stack React query. Here we have to add some default options like queries. Here we have to add on stale time, like by default caching time, which is going to be 5 minutes. So these are front-end cache, not back-end cache. This is different, definitely. Don't get confused here. Why you're doing twice? We're not definitely doing it twice. This is for preventing our front-end side to fetch data for multiple time from our back-end side. Yeah. So refetch on window focus, we have to make it false. Otherwise, like when you're going from one tab to another tab, it will again refetch the data, which we don't want. Retry, just one. Yeah. Then after this, here we're getting the query client. Then from here, we can say return query client provider, not provider props. It's just query client provider. Just copy this name, query client provider. Query client provider. All looks good though. What's wrong here? We have to pass client, which is going to be the query client. Alright, so I found the problem why the error is coming. First of all, in here, make sure to change it to TSX, not TS. Secondly, there's a syntax mistake in here. Right now you can see there's no error, and we can return the children from here. We can save it. We have to must make it use client, otherwise it will give some error. So make it use client. That's it. Let's come back here, import our query provider, and here we go. We can save it. We can come back here now again, and now in here we can say query key, which is going to be API keys and query fn. In this query function, let's add async function, because this is going to be async function, and we can say const token await get token, const response await fetch the process.env dot next public server URI slash API keys. This is the endpoint, and we have to pass here the authorization tokens, so something like this, same like this one. And after this we can say const race equals to await response.json, and we can return this race. And here we can say enabled if the is loaded is true, and the is signed in is true. Then now is loaded is signed in, these are basically coming from our hook. Let's come back here. From here, before this use query, we can say const something from use user hook from clerk next.js, and inside here we can add the is loaded and our is signed in, and we can come back here. Now all good in this API keys function. This is ready. This is for like the dynamic data. Now in this refresh keys, we don't have that, that's why. So for like creating on API keys, we can do one thing in here. We have to just add this line to refetch the like data. We can call query client from Tanzdak React query and invalid queries, and we have to pass the query key, which is the API keys for our query key. Now query client, I did a small mistake. Query client is going to be a variable, which is basically coming from this use query client. Yeah. Now let's come back here again. After creating the key, we're revalidating it. Okay, now here scroll down and let's see where's the next error. So the next error is in here, I guess. Revoked selected. Yeah, so here we can add the same line. So this is for revoking the key. So for this project, we have definitely revoking features like the delete API key or revoke. It's the same thing. For now, let's keep it empty. For now, let's keep it empty. We don't need to do anything in here. Yeah, we will work here later on. That's it. Now we can come back here. We can give on reload. It's loading forever. Why? Let's try to see. So it's giving on quotes error. Okay, it makes sense because we're giving request from localhost 3001. That's why. No problem. Let's come back to our services source main.ts, and we have to do here some configuration. Like we have to set up here code, so we can do one thing. After this app here, we have to make body parser false by default. Why? So that like we will have webhook feature in the future, and for webhook we have to keep it like the body parser false, so that that can reach out to our server. However, for the other parts, we'll definitely make it true. For now, let's say app.set global prefix API. It's like we're setting on global prefix, so that's why our endpoint is going to be the 8080, like localhost http localhost 8080/API. Then slash, we have to set here on version, so we can say enable versioning. The version type is going to be version type .uri, and default version is going to be 1. Yeah. And the next line, the important one, that app.enable course origin, make it true. And the methods, just add all the methods like get, head, put, patch, post, delete, and options. And credentials, make it true, so that we can like receive the server side only cookies. Yeah, and after this, for now it's fine, but we have to write some more code. But for now it's fine. When we have to write more code, when we will set up the webhook, that time. And one more thing, we can say app dot use global pipes. Here we can add new validation pipe, whitelist, make it true. Forbit unknown, sorry, forbit non whitelisted, make it true. And transform, make it true as well. Yep, we can save it. That's it for now. It's fine. If we come back here again, wait, it's saying class validator package is missing. Okay, so because we're using the validation pipe, that's why I think we have to install this. So npm I class validator inside our services, we make sure to install this library. However, I think I did some spelling mistake. Class validator could not be found. What? Class validator nest.js. Yeah, so just copy this and paste. Yeah, that's it, ready. So I added a wrong spelling, that's why. Now we can again start the server. npm run start dev. And here we go, all good. Let's come back to here again, give on reload. Internal server error. Okay, let's see what's wrong. It's saying cannot read properties of undefined reading ID. Okay, no worries. Let me see one thing from controllers, modules, API key controller, reading ID. We're listing the all API keys from here. And it's saying cannot read properties, reading ID. I think that the reason is in here, the user ID is not available and we didn't add here like our guard yet, that's why. However, if we console log like this request.user.id, you will definitely notice it's fully empty. So what is the solution in here? Can we create the API key like this? Can we create the API key? We cannot, because we have to pass the user ID. And user ID, we don't have it in here. We have to create our AuthGuard to retrieve the user ID from the token we are sending in here. You can see we're sending the bearer token. From here we can add it. And however, for the API keys, how we're doing map from keys, why? We don't need to do that. We will do map from this API keys, not keys. Same here. And all good in here. Instead of keys, make it API keys. And the type is giving error, which is very natural because we still don't have any type for keys. That's why. Here you can see key row, which is in here. We're not having fields like this, so we can delete the key rows. Let me see here. We don't have keys, so let's make it API keys. And anything else? Let me check. The code base is like older. I mean, it was the previous code base, so that's why we're updating a lot. Fine, no problem. We can fix all of this. Status color, cannot find status color because we deleted the status color. Yeah, We don't need to delete it. Let's make it any. And here, change it to API keys. Yeah. And still more 6 errors. We can easily fix, but that's not any solution if we add here any for the API keys. However, we cannot define type like this in here. Can we type like this? No, I don't think so. Okay, fine. But and one more thing, that is loading. So here we must have to add on line that if the is loading is true, then return null. Now API keys dot map, let's say any, and this is the number, the index. One problem solving done. Definitely it's just temporary solution, like we're adding any for the type. We don't know the status, or even it has the status field or not. We're kind of like blindly doing it because we don't have the data yet. However, no problem. Just 2 more type errors here and here. Just make it any, and same in here, any. We can save it, but it's not going to solve any problem. You can say API keys.filter, it's giving error. API keys.filter is not a function. All right, I find out the problem, the solution also. And first of all, we have to come back to our API key controller. From this list API key, which one is giving error, because the request.user.id is not available. So just add it something like this, just a temporary value for now. Okay, definitely it's not going to be the final one. Just for now, just a static value like this. Now, even if we try, you will see another error. And the error will be basically from our backend side. 1 minute. So network, see 500 error, and it's not showing here, but it will definitely, like, it's giving another error for database connection problem. And the solution is we have to come back to our this database module, and after this Drizzle DB, we have to add this line neon config and WebSocket constructor and WS means the WebSocket. Import WS from WebSocket. Make sure that you are installing this WS library like this, that npm iws, and then we can start our server again. And this time you will notice after adding this ABC in here, this API keys, just give on reload. The API keys, it should not give error this time, but still it's giving error. Okay, fine. Let's come back here. Let's do one temporary thing for now. That is API keys, make it API keys data. And const API keys is going to be for now empty array. Yeah, what's it saying? Okay, yeah, so for the type, let's say any. We can save it. Here you go. It's fully empty because it is loading, that's why. However, this time you can see API keys is giving 304 and 200. It means we're getting on empty array in here. Perfect. So we can add here API keys data or an empty array. You can see no error. However, we have to add here on loader, which we will do. But first, here this is saying loaded saved API keys. All right, let me do one thing. Let's delete this and scroll down in here. The loaded saved API keys, it's coming from here. Let's delete this state. We don't need that at all, because we are having our is loading, and there is another error because is loading keys. It's going to be is loading. Yeah, so when you're giving on reload, see loading API keys and no API keys created yet. So right now we can create one. However, even if we create, let me check one thing from the code base. So the create API key or generate generate a new key button. So create key, all looks good, but one thing is not okay in here, and that is this API keys. So for creating the API key, we're still passing the user ID. Let's do one thing. Let's check our user ID from Clerk dashboard. So let's come back inside here in Clerk dashboard. Then we can find out the user ID. Here you go. We can copy the user ID. For now, just paste it in here since we're not having the guard yet. So we can do it. It's the only option now. Let's come back here. Let's hit generate a new key. What's happening? Okay. So when we're hitting the generate API key, you can see your new API key. This is basically the API key. You can hit the copy button from here to copy the API key. If you come back here, you will notice it's already in here. So it's working. It's not like that it's not working. We have to copy this and we can say I stored it safely. However, this time it's showing nothing, which makes sense. We have to update few things, not few, a lot of things, but it's working, which is a good news for us. We can store this API key somewhere safely. Let's say in here secret.txt just for now. Let's paste our API key. Okay. All right. Now these values are not showing here, so we have to make it visible. We can do it. First, we have to check our API keys. So we are basically getting the ID, prefix, last used at, and revoked at. The API key name, we're not having any name. We're basically having prefix instead of name. So we can say prefix k.prefix. We don't have scope. We have created it last used and status and actions. Yeah, we don't have scope. So here we can see the prefix in here. Now created at, where is the created at? Here you go, created underscore at. So created at, here you go. However, it's not looking good because we have to use a library. I like the library. It's called timeago.js. So npm I timeago.js and start our server again. This is inside main dashboard. Now in here we can cut this. We can add format and we can pass this. Now for the format, we have to wait. Yeah, it should be something like this. Now format, we have to import it from timeago.js. Import format from timeago.js. Yeah, we can save it. Here we go. You can see created 3 minutes ago. Last used at, this is completely empty now because it's null. So when the last used at is null, we can check one thing. Scope, we don't need scope. Let's delete scope. Name. This is for key detail drawer. Okay. We are having here key detail drawer. We even don't need the key detail drawer, however, since it has that, no problem. Now after the key dot created at in here, last used, it's going to be last used like this. Last underscore used underscore at, or like no uses yet or something like that, we can say. Yeah, no users yet. Let's make the N to capital. No users yet. Status, for the API key, we're not having any status like that, but if the revoked at is not true, okay, we can say one thing: revoked at is not null. Revoked spelling is wrong. It should be something like this. So revoked at, if it's not null, then status going to be active, otherwise revoked. Yeah, same here. We can copy this, we can add it in here. Let's come back here. You can see status, it's showing revoked, which is funny. Okay, it should be the opposite. Revoked at is not null. If null, then active, otherwise revoked. Yeah, now it's active because it's originally active. Now for revoking, it's not going to work. However, in active keys, let's change to active keys in here. Active keys, active count, we can say 1 minute to revoke. I have to copy this line again. Yeah, and here we can say k.status instead of k.status, k.revoked at if it's null. What the hell we're doing, bro? Yeah, this is actually makes sense. You can see revoked is not null, then yeah. And same thing for here. Instead of k.status equals to active, make it k.revoked at equals to null. Then yeah, active key is 1, revoked 0. Last generated time, this is for created at, yeah, 6 minutes ago. Perfect. Okay, all looks good. Just we don't need this drawer, or even if we're having it, that's fine. That's a like new feature we can say, but we have to change the values because it's right now not showing us the values, which makes sense. It's going to be created underscore add and format. Yeah, created add key row selected. No, it's going to be any. We don't need this key row. So you can see created at 7 minutes ago. Perfect. Now next one. I'm losing the code very fast because it's a very big code base. All right, last use, it's going to be last used at or null, but we have to add it inside format, except this because null cannot be formatted. Yeah, last used. Oh, sorry. So since it's null, that's why it's showing just now. Let's do one thing. If selected dot last used at available, then this. Not available, we can say if not null, then this. Otherwise, no uses yet, but in a double quotation. Yeah, no uses yet. And status, for the status here, let's copy this and let's add it. Yeah, so k, instead of k, we have to add here selected. And same here. Yeah, we can save it. Here we go, status active. Now revoke. If we hit revoke, what's going to happen? Let's see. For revoke, revoke selected. Okay, so the function is empty right now, so nothing will happen. But what we will basically call in here, we will do nothing. We will just call the delete API key, this one, and then this will just revoke the API key. And if you hit this generate a new key, it will create another new key for you. But one thing I would like to check, generate API key, sorry, new key here. When we're clicking here, the create key, set is creating, yeah. Here we can say, if the set, like set is creating is true, then generating, otherwise generate is creating, not set. Okay, is creating if it's true, then generating or generate new key. Same in here, disabled if is creating is true or limit reached is true. Then, so by default it's false. When we're clicking to create a new key, it's getting true, and at the end it's getting also false. Perfect, all makes sense. Even if you right now hit this generate API key, you can see it's perfect, it's generating, and here we go. We can copy this, we can hit that I stored it safely, and yeah, this one is the new one. Just one thing is not looks good here, that this data should be above and this one should be down. And one more thing about the format. So format here we can say capitalize. Yeah, done. Ooh, okay, all good. Now what next? The revoking one. We're gonna make it, no problem. We just have to copy this try catch simply, and set is creating again, make it true. No, we will open 1 minute. Let me check the code base a little bit. So when we are hitting the revoke, my brain is confused. 1 minute. The revoking, let me see, revoke, and anyone will be confused in here. Like a big code base like this, the confusion is coming because it's been a very long time I write this code, and right now I am just like fixing things in here. That's why writing code is easier than fixing a code base. Here, when someone is clicking the revoke button, we're selecting it. Yeah, that's why like it's showing in here. What if we click here, revoke? Okay, and from here we have to revoke the key. Okay, interesting. And here we don't need this logic that if it's default then blah blah blah, because we are not having any default key like this. It was the older version of 1minute locks. Okay, let me delete. Yeah, now if it's like a name and true, then active count, yeah, fine. The revoked, from here, revoke dialog is this state connected with this state. Okay, siderear. Siderear. Yeah, this one. Here is the revoked button. Okay, so we are basically again calling the revoke selected. And wait, is it creating another API key? No, okay, that's great. So revoke selected. From here, if we are clicking the revoke button and active count is more than like less than 1, then selected name, we don't need this one. All right, now in here, for deleting the API keys, it's delete, and we just have to pass the ID, which is the selected dot ID, I guess. Method is going to be delete, and these things we don't need anything, just revalidate the query key. Yeah, and set is creating, it's not need to be true because we're not making the set is creating. We can add another state if we want, or even instead of making a function like this, we could make it also a query function, which would also work, but fine. For now, let's add here another state by giving them something like is revoking, and set is revoking, use state initially false. At first, after selecting, make it true, and finally in here make it false. Okay, selected.id, I just want to check it here, selected.id, then return. Now again come back to the revoke button and disabled. First, if the is revoking state is true, and then the rest of the logic. Yeah, and here we can say if the is revoking is true, then revoking, otherwise revoke. Yeah, we can save it now. Let's come back here, let's hit revoke button, and cannot revoke the only active API key. Okay, let me see the active count. Cannot. What is the error message? Where is this? Okay, here it is. If the active count selected.name, there is no name. Active count and this. Ooh, we don't need this at all. Just delete the tooltip content. Okay. Cannot found API /v1/delete. Oh, sorry. Oh, my brain is getting exhausted now this time. Yeah, thanks, sir. Going on. Here, we have to add these API keys. This was like the entry point. Yeah. Now if we hit revoke, internal server error. What is saying? Selected.id cannot read property of this. What? Why? Console log selected. Yeah, there is ID in here. What's wrong? And in backend, what's the error? It's saying cannot reading undefined. It's reading. Yeah, because in delete here in delete request.user.id is not available. That's why. So just make it like this. Yeah. Now it will work. Revoking. Done. I think it should be deleted now. Yeah. Let me give on reload. OneMinute. Here. Revoked add. They both have revoked. Yeah, you can see that's why it's saying revoked. And when the status is revoked, you cannot revoke it again. Key.revoked add is null. Yeah, no actions button because it's revoked already. You cannot revoke it again, bro. Okay, fine. So let me just copy this. In the drawer, let me add it in here again. Yeah, you can see no revoked add option right now because it's already revoked. Yeah, while working, but it's not definitely like the way we want it. We can right now generate a new one. Like let's hit generate new one. We can copy and we can hit that I stored it safely. And here we go. It's in here. And everything is fine. But one thing is not fine. And that is we have to make our AuthGuard right now. Without the AuthGuard, this is not going to work perfectly. Yeah, it's very, very important. So yeah, right now, this work is done. Just one thing I would like to change in here, that revoke selected. Here we have to close the side drawer. So the side drawer is in here selected. If it's true, then we have to make it a null basically. Yeah. So set selected null, we can make it, then that will be like close. And yeah, that's all. We don't need to do anything else. Yeah, right now even if we try this, you can see revoking. Yeah, here you go. All good. That's it. So right now our next task is to start to work with the AuthGuard, and it's very, very important. So right now, don't waste any time. Let's start to work with AuthGuard. All right, welcome back to a new part. And in this part, we're going to start to work with our AuthGuard, and it's going to be a fun work. So let's get started. Let's come back inside services folder and source folder or SRC folder, and inside guards, we have to create a new file by giving them AuthGuard. Inside here, we have to start to work right now. And first of all, in here, we're gonna add our injectable decorator from nestjs/common, and we can say export class AuthGuard and implements our can activate from Nest.js common, and let's use your constructor. We have to inject our Drizzle DB. We can say private DB, the type. Let's add type. It's like neon HTTP database type of schema. Now schema is coming from our database schema, so we can say import everything as schema from // database and schema. Regarding the neon database, let's import our neon database, import neon database from Drizzle orm/neon http. Yeah. After this, we have to inject our Redis client, something like this, and let's import the Redis client. Yeah. We can come here now and we can start our async, can activate, and context is going to be execution context. Very good, but here don't need to make it long like this. Let's say it's going to be a promise. It's going to return a promise, and its type is going to be boolean. So it's basically going to return a boolean. Now we're gonna receive our request in here, so we can say context then dot switch to http dot get request, like the header request, or yeah, we're basically going to check the headers. So here we can say API key, which we're getting from request dot headers, and it's something like this, that X API key. Yeah, so if you're like passing the API key, then we're getting that in here. And however, let's import Redis from iRedis. After this, if there is API key, then we have to check that is the API key valid or not. So we can use here on function, on helper function, that extract key ID, which is basically going to extract the public ID from our API key. Extract key ID, it's going to be a helper function in this utils folder. So let's create a new folder by giving them utils. And here we can say, let's say API key verifier dot ts actually. Yeah. And we can write here our extract key ID function, which is going to receive the plain key, which is string, and going to return string or null. Yeah. If there is no plain key, or the plain key dot starts with our OML and underscore, meaning OneMinute logs and underscore, then return null. Now we need the parts of the API key, so we can say plain key dot split and underscore. If the parts dot length is more than 3, then return the null. Now we can say const key ID parts, and let's get the first index from our like parts. From first index means basically the like public ID, because again, try to remember this is our API key OML, the flag, and first index doesn't mean this one. Okay, I think you know this is the basic JavaScript. This is the first meanings actually 0, and 1 meanings the public ID, and public ID, and last one is like the secret key. So we are basically targeting the public ID, which we need to target. That's basically the key ID. Now we're gonna check the key ID with a regex pattern. Very important. We're gonna check that is it really an UUID or it's something like a random value. So we can check that with this, that if it's a real UUID, then very good, otherwise return null. If it's not, then return null, otherwise return the key ID that yeah, it's valid. So it's just like a validation layer. We're validating it that the API key is valid or not, especially the key ID. Yeah, so this is the first layer of security, and we can say if the key ID is not somehow valid, then we can say invalid API key. We can throw a new unauthorized exemption error, and after this, if it's valid, then we have to digest the API key. Now we're not going to eat the API key. It's basically meaning we are just like changing the API key, especially this key ID, into a format, which format we will like add inside our Redis, because we don't want to add the raw data, like the raw value into Redis. That's dangerous. That's why we're going to use this digest. This digest is nothing, it's just like on helper function. In this utils, we can create our key digest.js. It's going to use the crypto library, the built-in library of Node.js, to change the value to a different like hash value. Not hash, it's like an encrypted value, because hash means you cannot like check it, sorry, you cannot take it back to the raw version, but encryption means you can take it back into the raw version. So there is different in hashing and encryption. And here we are going to like encrypt this with an secret key. So we can say process.env.redis key secret. Very important. We still don't have this, we will create. Now if the Redis key secret is not available, then we can return an error for our internal service that yeah, Redis key environment is must required. And otherwise we can basically we can like use the SHA-256. We can encrypt the data. We're using this one, the like we're digesting it to the hexadecimal value. I think so. HEX means hexadecimal, it should be. We can save it. We can come back here. Let's import digest. We can save it. Now for the Redis key secret, let's do one thing. Let's use OpenSSL and random hexadecimal 32 characters value. So just copy this and add it as the Redis key secret in our .env. I'm not doing it in .env. I created actually an env example for you so that I can show you that how I'm adding the value. So something like this, and the Redis key secret. Just add that in here. Yeah. But let me add in the real env right now from another screen. Yeah. And we make sure to use a different value for the Redis key secret by using OpenSSL. Even if the OpenSSL is not working for your laptop, we make sure that you are having OpenSSL in your device. So you can say OpenSSL for Windows or for like Mac, which one you are using. If I'm using Mac, so I can say OpenSSL for Mac. You can see this is the command to install OpenSSL, brew install OpenSSL. For Windows, it might be different. So you can definitely check it out and install it if it's not in your like device. Or even you can use like any application that, let's say, secret key generator. There are so many applications like random keygen. You can use all of these to generate it. Yeah. Now after this, we can come back into our AuthGuard again, and from here, after our digest, we're basically getting our D in here, like the digested version. Then we can say const LRU key, and we can store the version and our key ID as like the LRU key. Now key ID is coming from here. K is not going to be capital. Yep. And we can say const now. We need a date. So we can say date dot now. After this, we can add on try catch statement. And inside here, we can say const C and local cache. So local cache is our LRU setup. So we have to pass here the LRU key. Now local cache is in here. Let's add our local cache, that new LRU cache from LRU cache and cached key. So this is our cached key from the configs, this one. And what is this observable doing here? We don't need that. Now come back again in here after the C. This is basically we're trying to checking the data from the cache if the like API key is having in our local LRU cache. So if the C and C dot expires at is more than now and C dot API key digest is matching with D, then we can set the request user value, that ID is going to be C dot user ID and the key ID. Yep. And after this we can void the this dot track API key last used. Now this is an interesting function, not function, it's basically a private module which we're going to create right now. This is just going to check or track our API key last used. So after every time when you were like doing something with the API key, it's going to track the last use time. So let's add the private module in here. We can say private async tracked API key last used. It's going to receive the key ID, which is going to be string, and we can check for the lock key. Yeah, there are going to be locking mechanism. If there is like any suspicious activity detected, then we can say OML on minute logs. One thing I would like to again check for one time, that is inside our configs OML. See here, it's not capital. So okay, fine. Here also then we can make it not capital. Yeah, let's keep it OML like this. Then API key, then last used lock. We can pass the version and the key ID. Now const okay, await this dot redis dot set the lock key, make it 1, and expiry it's going to be last used debounce seconds, another variable. So last used debounce second, it's going to be basically 60. Let's come back to our utils, sorry, not util configs, and let's add it in here. At last used debounce second is going to be 60. Let's import it. After this, the next one we can add nx. Yeah, that's it. Now if the OK is not true, then we can return the method. Otherwise we can say await this dot redis dot h set the last used hash, the key ID, and date dot now dot to string. Yeah, done. That's about our track API key last used. So it's basically tracking our API key last used. It's doing nothing else. After this, we can return true from here. Now, otherwise, our key digest from Redis, when the local LRU doesn't have the data, then we're going to check it inside Redis. We can say OML API underscore key, the version, and the key ID. Yeah. Now our digest, this is different. Our digest, you're gonna call await this dot redis dot h get all with this r key digest. If the r digest invalid equals to 1, then we can throw a new error that unauthorized exemptions, that with error messages like this, that unauthorized. Yep. Next one, if our r digest API key digest and r digest API key digest is not like the D, then same unauthorized. We're basically verifying the key digest. If it's not matching, then it's like something is wrong. It's unauthorized. Yeah. If it's matching, then r digest dot user ID. If there is user ID, then we're gonna set up it again in our local cache. Like r digest dot user underscore ID. The API key digest going to be the D and expires at now plus our LRU soft TTLMS, another variable, and this TTL is basically 5 minutes. So let's do one thing. Let's come back to our configs file again and let's add it in here. Yeah, we can import it, we can save it. After expires, after this, we can set our request.user value with this user ID, user underscore ID, sorry, r digest, wrong spelling, yeah. Then the key ID and void this dot track API last used and pass the key ID in here and return true. Yeah. Now finally, if it's not even in Redis, then we have to check it from the database. So we can say this dot db dot query dot API key dot find first, where our, let's use AND operator from Drizzle ORM, where an EQ from Drizzle ORM, the AK ID is matching with the key ID and our AK dot revoked at is null, then it means the API key is ready to use. Then we can like add the value, then user ID, we can like fetch it and we can return this, then revoked at true. Yeah, we're selecting basically these fields. That's it. Now if no record, then we can throw an error that this is unauthorized, the data is not valid. Now if is, after this we have to must check the signature, right, the hashing. So that's why we're gonna use here argon2 again. So argon2, let's import it in here, that import everything as argon2 from argon2. Now here, if it's valid, then good. If it's not valid, then definitely this is an spamming. So when this is not valid, we're gonna add something to our Redis to prevent the user to send multiple requests again. We're gonna add the rkey digest, and invalid, we're gonna make it on. So the user is temporarily locked for a certain time. for sending requests to our server, because he was trying to doing something unethical thing. That's why. So this is a good security. And after this we can say this.redis.expire, and we can add the archdigest, and we can add here Redis hard TTL, which is I think again 5 minutes, or I think it should be more, it should be 10 minutes. Yeah, so we can add it 10 minutes, and TTL, we can save it. And finally we can throw the error that unauthorized. So we're not letting the front end side to know that what's wrong. We're just saying, yeah, it's wrong. Otherwise, like, it can happen that hackers is always checking the error message. So, or like who is spamming, they're checking the error message. So that's why in here everything is like the same message, that unauthorized. Yeah, just for a little bit hard security. Because the thing is that in here the user is not doing anything, it's completely automated. This guard is not for like manual field, it's just like an automated thing. So when there is something different, it's definitely, it means it's not a normal request, it's something like a spamming request. And for those users, we're very strict. We're not letting anyone to spam with our application. After this, we're setting our key digest with the user ID and like API key digest. If everything is fine, if it's valid, then, if it's not valid, then we're like locking the user. And finally we are expiring, we're adding an expiry in here with the key digest. And let's add our this information into request.user, and finally track the last use of the API key. Yeah, and return true. If it's catch any error, then console log the error and throw the same message again, that unauthorized. Yeah, so this was for API key. But since we are using the same thing inside in here, we're not sending API key when we're sending requests from here. We're sending bearer token. And for bearer token, we have to follow a different approach, which is easy, by the way, not hard. Like after this, if API key, then everything is good. If API key, then our logic. If it's not API key, then we're gonna check the token, the bearer token. So we can say request dot headers dot authorization and dot split the first index. So basically we're getting the token from here. If no token, then missing authentication token. If there is token, then we can use another try catch statement. We can verify that token. So a verified token, await verify token. So verify token is basically coming from Clerk, since we're using Clerk as our authentication provider, and we have to install this library. Let's go to services. Like if you're inside services, you don't need to go anywhere. Since I was outside, that's why I came back into services. Now npm I Clerk backend. Clerk is really lifesaver for this type of thing. You can see how easily we're setting up the middleware. We're doing literally nothing. We're just letting the Clerk to verify its token, and we just have to pass that token and definitely the secret key. Otherwise, like anyone can check it without the secret key. So Clerk secret key, we make sure that you are having it in a .env, in the services.env. Then request.user, the ID, and like the verified token. Yeah, and then we can return true. Yeah, if it's catch any error, we can throw on unauthorized extensions that something went wrong. Please upload your file by using our SDK. So this is saying please upload your file. We can say something went wrong, please use our SDK. We can use something like this. Yeah, we can save it. Clerk secret key, let's check our env example, clerk secret key. So we have to add it. Let me add it from another screen. Clerk secret key. You already have clerk secret key inside main dashboard.env. So you can copy it from there and paste it in here. Yeah. I'm again coming back in .env.example. Alright, and I'm closing that one, and here I'm just saying your clerk env secret. And here let me write the command that open SSL what is that, and this random, or use a password, or use something to generate a secret key. Yeah, that's it already. So our AuthGuard is actually ready right now. We can use it properly. Let me show you. Since it's ready, I want to do one thing. Let's come back to our modules and API key and API key controller. Here, let's delete all of this horrible thing. We really don't want to add static value for sure. We just have to add here our AuthGuard. So AuthGuard we have to add in here. We can say use guards and AuthGuard actually. Yeah, we can save it. And let me run our service, says npm run start dev. I think it will give an error. What's wrong? Unexpected token, where? I hate this cache related error. It's for sure not any real error. Just do one thing, delete the dist folder, clear everything, and in our app module, I think we have to use the guard. No, this is a guard. This is not any like module, I guess. AuthGuard. Yeah, so we don't need to use it anywhere. Just write the command again. What the hell? Dot nest. Let's say npm I again, and npm run start dev. Very weird. There is even not any dist folder. I don't know what the hell is happening. AuthGuard. All looks good. You're saying what's it? What you're saying? Unexpected token equals to in where? I don't know. Just save it and somehow run it again, and here you go. It's working. So yeah, sometime if you're even experiencing the same error, just fix the syntax. It's definitely not our mistake. If we delete the like node env, sorry, node modules and reinstall everything, it will not give any weird error like that. However, right now you can notice without even our like static value, it's working. We're fetching the data. It means our guard is actually working. And again, let me show you that yeah, it's actually working. From here, from our list API keys, we can console log the user ID and come here, give on reload. Here you go. You can see our user ID is in here. It means it's actually working. So our guard is perfectly working. At this moment, we're going to start to work with our ClickHouse setup. But before that, I want to show you something because I did some mistake in our API key service. So let's come back to our delete API key module in here in this API key service, API key modules. In here, be make sure to add this equals to API key.id and key ID. Otherwise, when we are deleting API key, it's going to delete all the API key for the logged in user. So we must have to delete the selected API key. So be make sure to add this line in here. Another mistake I did somewhere, and the mistake is we have to delete OML API key, not VMX. So this is a mistake. Be make sure that where is VMX, just change that with OML. Don't do the mistake. Okay, yeah. And after updating these two things, we're good to go. I'm glad we found this bug during development, but imagine if something like this reached production. In this case, revoking a single API key would have accidentally revoked all API keys belonging to that user. That's exactly the kind of issue that's easy to miss when a project starts growing. As more features get added, manually testing every workflow becomes harder and harder. And that's where automated testing tools like TestSprite comes in. TestSprite starts by analyzing your applications and identifying important user workflows and use cases that should be tested. Based on those workflows, it automatically generates a test plan that you can review, edit, and refine before execution. And after the test runs, it provides a detailed step-by-step walkthrough showing exactly what happened during each test, making it easier to understand failures and investigate issues before they reach production. What I like is that instead of only looking at source code, it focuses on validating how the application actually behaves from a user's perspective. It supports both MCP integrations and their web portal workflow depending on how your team prefers to work. But since currently we're in the development mode, we're still developing our product, we cannot use their web portal at this moment. So we can use their MCP server for testing this full application again. And after testing our project, we can ensure that everything is fine in our API key service and AuthGuard module. So let's start it. And you'll find our TestSprite website link in my video description box. You can click from there, or you can also type the link you're currently watching on the screen. And after coming back to TestSprite website, you can click this Get Started for free if you're for the first time. And if you have an account, then you can click Sign In from here. Since I do have an account, that's why I did sign in. After doing sign in, you can see there is MCP test in here. But we have to right now set up TestSprite MCP server into our code editor. And it's very easy. Just click this documentation from here. And after that, from here, hit this installation. And from here, you can see you can set up TestSprite to your any IDE. It can be VS Code or Cursor or Tree AI or whatever you are using. So since we're using VS Code, we will right now going to set up it in our VS Code. And to set up TestSprite, the first step is come back to our TestSprite again in here and click this API keys. From here, we can actually create an API key. I already do have an API key, but I'm going to revoke it and I'm going to create another one again by giving name, let's say 1Minute logs. We can hit create from here. We can copy this. We can hit close button, and after that we can come back to our project again and paste the API key somewhere like this. We need this after some time. And after that, you can see the next step is like installation in your code editor. So since we're using VS Code, we can select VS Code. We have to press Command Shift P or Control Shift P if you're using Windows. So let's say I'm pressing Command Shift P, and make sure that you're having this GitHub Copilot extension installed in your VS Code. Otherwise, it will probably not work. For me, you can see it's already installed. After installing, you will see a button like this in here that open in agents. And this is like my ChatGPT because I connected Codex model in here. That's why. So after that, let's press Command Shift P, and from here you can see MCP add server. And here choose the type of MCP server to add. For us, we need to select the Studio installation type. So we can select Studio, this one, that command Studio, run a local command. And here we have to write a command, and the command is going to be actually this one. So we can copy this command. We can come back here again and we can press enter. Now here we have to give a name for our MCP server, like an identifier. We can say TestSprite. And for the workspace, you can select global or you can select workspace. Workspace means it's going to target your this individual project. So we can select workspace. After selecting workspace, you can see it's automatically creating a new folder in our project by giving them .vs code. And there is one mcp.json file in here. We have to give here a comma. And after that, you can see we have to add here our env file. So env actually outside this. So something like this after this args. Yeah. Here for the API key, your API key instead of your API key, let's paste our API key. So we can cut this, we can come back here and we can paste it. After that, we can save it. And that's it. Our work is actually ready. Right now from here, we can click this start button and it means our MCP server is right now running. But even MCP server, when it's running, we make sure to restart our like the window. So you can type this, that developer and reload window, and let's click that again and then hit start button. That's it. So right now the MCP server is ready. We can click our like any model which we're using. So for me currently I'm using Codex. So I'm opening Codex in here and I'm saying test our API key service by using test sprite MCP server. And when you're writing this command into Codex, we make sure that you're inside this mcp.json file, and then we can hit enter. And right now it's going to actually use this test sprite MCP server to test our project. All right, you can see this is the testing results. The first few tests are failed, which is very normal because you can see here it's regenerating the API key with Clark JWT, but we didn't provide any Clark JWT. That's why it failed, which is very normal because we wanted it to be failed when you're not providing any JWT keys. In here, access API key management with invalid token, it's working, it's fine. Actually, everything is working in here. This MCP results, if you even go inside here, you can see the past results and they're basically giving us some results from here. So all of them are actually perfectly working. And right now we can start to work into our next module. Right now we will start to work with the main like infrastructure layer for this application, and that is like setting up ClickHouse and start to storing logs. And we also have to set up Nets JetStream, like the message broker, which I was explaining in the system design part. So right now, let's start to do it. In this services folder, in this source folder, we can create a new folder by giving them ClickHouse. Yeah, in this ClickHouse, we can create our ClickHouse client. So we can say client.ts. Now we have to install a new library. So we have to go to services and we can say npm I clickhouse/client. And here we go, it's ready. Now here we can import something from our ClickHouse/client. We have to import our create client from here. After this, we can say we can create an object, something like this, that required env vars means the required env variables. For this, we need our ClickHouse underscore URL, the database URL, and it's going to be process.env.clickhouse underscore URL. Yeah, and next one is ClickHouse user, like the username. So it's going to be process.env.clickhouse user. Next one is ClickHouse password, like the password for the user. So sorry, it's going to be password. Yep. Next one, ClickHouse DB. it's going to be GB. Yeah, ready. After this, we can add here on validation layer by saying missing vars. We can say object dot entries at the required env vars, and we can add here and filter something like this. Yeah, so the value when there is no value, and map with the key and return the key from here. Yeah, so these are the missing variables. If the missing variables dot length is more than 0 or even 0, then we have to throw an error. We can throw this inside our console.log or console.error so that we can understand, yeah, there is something wrong. We can say missing required ClickHouse environment variables, and then we can also add another console error, something like this, that using default values, this may cause connections issues in production. Yeah, after this we can export our ClickHouse. So ClickHouse, the main function, we can use the create client in here. We can pass the URL, which is going to be our process.env.clickhouse URL or http localhost 8123. This is the port for ClickHouse, and username we have to pass. So username, we can copy this instead of ClickHouse URL. We're gonna pass here the username. Yeah, or by default we can set it to default. Now the password, we can pass process.env.clickhouse password or empty string, and next one is the database, which is going to be process.env.our ClickHouse DB, or we can say logs. Yeah, that's it. So our ClickHouse client setup is ready. Right now the next task is we have to create on schema for our ClickHouse database. So let's come back in this schema.ts new file in this ClickHouse folder, and let's create our create logs table. We can call here async, because this is going to be an async function. Then await ClickHouse from ./client.comment. We can add here and query comment. Now we're basically going to write here the raw SQL. As I know, this is the only options. There might be some other options, but yeah, we're going to write here raw SQL code like create table if not exist. The table name is going to be log.events. Inside here, we're gonna first pass the key ID, which is going to be string, user ID, which is going to be string as well, and type, which is going to be low cardinality and string. Now, what is the meaning of this low cardinality? The meaning is that basically low cardinality is a ClickHouse data type modifier that optimizes query and storage performance for columns with repeated values. So repeated values meanings like, let's say we're adding this low cardinality for type and for things like a message or app name or this type of things. Now, where to use it and what are the benefits for using this low cardinality instead of string? Why we're using this low cardinality? Basically, when you are using it, it's going to take less disk space. It's going to replace the all long strings with 8 or 16 or 32-bit integers references. And because of this, we can have a very fast queries because of this. And since it's like taking like replacing the long strings with a shorter value, it's going to use lower memory. That's why all of these are very beneficial for this type of like things. So yeah, that's why we're using low cardinality for these fields. Now message we should keep it string because this is going to be unique. Low cardinality is good when the value is not going to be always unique, like this one type is, it can be same most of the time. That's why we are using this one. Same for the app name. App name can be like similar for so many logs, so that's why we should use low cardinality in here as well. Same for the environment, like which environment, like production or like development. So it also can be same for a long time. Now importance, like how much importance the log value is. We can add here a nullable value and it's going to be integer 32. Like on a 1 scale, how much important this log is. Then subsystem, it's basically useful for microservice. So we can say nullable, meaning it can be actually like null. It's an optional field. We can add here string because this is basically a string. Now service, this is also helpful for microservice, like from which service this logs is coming from. So same string, nullable string. Operation, we can add something like this, that operation nullable and string. Yeah, so this is like which operation it was doing, like deleting something or like which type of operation the log is for. After this, we need our track. So this is basically like no one is going to pass it, but we're gonna add it automatically for tracking internally. This is going to be string as well, as is going to be capital. After this, security, this is going to be again nullable string. And metrics, like analytics related thing, so nullable and string. Now the timestamp of that log, so it's going to be date time, and default is going to be now. Yeah, and ingested at, very important. What is the meaning of ingestion? It's like a weird word we're using from the beginning, right? Ingestion. So yeah, I'm going to explain it right now. What is the meaning of this ingestion? So ingested at meanings like when the user, let's say our user, whoever using our application, they're sending the logs, and when we're receiving the logs inside our application, listen again, when we are receiving the log in our application, not including the latency, because there are definitely going to be a latency from on application, it's coming to our application. That application can be somewhere in the world. It can be in the Europe, it can be in the Asia, or it can be anywhere. So there isn't latency. So we are not calculating that latency. This ingested at meanings whenever the logs is landing into our backend system, and our backend system processing it and storing it to the database, that time is called ingested at. Not ingested at, that time is called ingestion time. Basically, let's say the users are sending logs toward logs/logs endpoint. Whenever it's receiving, like we are receiving the logs in here, and when our consumer, like the message broker consumer, is processing the logs in between, this time is called ingestion time. And this ingested at is basically here from the consumer when it's like ingesting it, when the log processing done, then we're adding that ingested at. With this, we can understand the backlog pressure inside our application. Now again, what is backlog? Backlog means how much pressure our application is going on at this time. Because if you go back to our dashboard, you will notice here there is on queue backlog, average latency, and ingest rate. So there are so many internal like analytics we're showing to the dashboard for making the users understand like how is our server health right now. Like for example, this ingest rate is basically the ingestion rate. Now ingestion rate, it sounds very weird. It's basically when our application or the producer is receiving the logs, the number of that logs That's basically the ingest rate. When there is a lot of ingest rate, that's going to be in here, like in 1 second, how many logs our the producer is receiving. That's the ingest rate. The average latency is when the ingestion logs is getting processed, that in between time is the average latency. Queue backlog means which logs are waiting into the message broker at that time. Let's say when they're like 10,000 logs in like every 10 seconds, then we're probably not uploading all the data into our database within after every 5 seconds. So there will be then some queue backlog. Queue backlog in meanings which logs are still waiting into our message broker. Those logs are queue backlog. Now after ingested add, we have to add here engine, which is going to be merge tree. Yeah, and this is all from like ClickHouse, so you don't need to worry for any of these. Then partition, we have to add here in partition. There is also partition in ClickHouse as like the if you have ever used Kafka. Yeah, we had in partition in Kafka. I think we also have partition in JetStream. Now by to year, month and date. This is like the format timestamp, and order by, it's going to be a key ID and timestamp. Now we have to set up on TTL, so we can say timestamp plus interval. There is another important thing you have to understand. 30-day delete we're writing here. Why this 30-day delete? What is the meaning of this? Very important. You have to must understand this, because this is also another business like model for any logging application. The thing is that no monitoring tools store the data forever. If you come to our pricing, you will also notice it in here. 7-day retention. What is the meaning of retention? 30-day retention, 90-day retention. The retention meaning is that after this day, the data will be deleted. We will not store your data forever. And no like monitoring tools does it. No one store it for forever. The reason is definitely like when you are adding a lot of data, it's definitely you have to pay money for that, for the storage. So that's why no one basically store it for a long time, and like you don't need that, because logs are not like all usefuls. Sometimes it's like the repeated data a lot, but it's also helpful because when there's something wrong, logs is the only way you can easily track that what's going on, what's wrong, or which service is having this problem. So that's why after a certain time the logs will be deleted. That's why you can see in here in our pricing we already we added here the retention date, that after 30 days your data will be deleted, after 90 days your data will be deleted. Yeah, but here we're saying 30-day delete because this is the by default value for now. In here we are setting up, or we're saying to ClickHouse that whatever data you are storing, after 30 days delete it automatically. We will not write any note cron or something to delete the data. It will be automatically deleted after this 30 days. And we can add here on settings that index and granularity. So granularity is going to be 8192. Now this is basically index granularity. In settings, yeah, we can save it. Alright, our ClickHouse schema setup is ready, but we have to fix few things in here because it's not fully ready yet. I mean, it's ready, but we have to fix few things in here. First of all, in these partitions, I said it's similar like Kafka or that JetStream, but in reality it's not. The message broker partition is different than ClickHouse partition. Message broker partitions meaning is like it's about message distribution and parallel consumptions. But on the other hand, ClickHouse partitions meanings how data is physically grouped on disk for storage management, like how we're planning to store the data on the disk, on the ClickHouse disk, on each group. So the partition is basically the group in ClickHouse. Here we said 30 days like for 30 days interval, we're saying partition for every day. It means for every day we're adding on group. But for our scale of the application, like we're not definitely making it for billions of logs at the first level. For this type of stage, we should not make it for daily partition. We should make it monthly. So here daily partition will create about 30 partitions for 30 days, which is not terrible, but it's basically unnecessary for, let's say, 100k or 10 million logs for the scale we're planning to make. So for that's why we can make it monthly partition, because monthly partitions are better unless you're ingesting huge volumes or we need to drop like exact days manually. So basically we just have to delete the date from here, then it's right now becoming monthly partitions, which we need. And in this order by, I did a small mistake. It should be timestamp first and key ID second. The query is then going to be like faster because it was opposite earlier. Yeah, so basically the timestamp, since like most of the logs we will filter by the timestamp, that's why we should add the timestamp first and key ID at the second. Yeah, that's it. Now everything is okay in here. Our ClickHouse setup is ready. Right now we're going to start work for setting up next JetStream, because we need our message broker right now, because without the message broker, like nothing is going to work, because the logs are at first going to be sent through the message broker, and the message broker consumer will use this ClickHouse to store everything. So in this next folder, we can create a new file by giving them index.ts. Inside here, we can export our async function like get nets by giving them something like this. And inside here we can say, actually we have to add here a late variable like late nets connection, which is going to be any or null. And in here let's add JC, means basically our JSON codec. So JSON codec, which we are importing from nets library. So import JSON codec from nets. Nets is not here because we have to install the library. We can come back here again. However, somehow my VS Code got restarted. That's why I have to again go to the apps and landing page and npm run dev, open new terminal, cd apps, cd main dashboard, and npm run dev, our services, and npm run start dev. Yeah, all good. And again services, and we can say npm I nets. There we go. That's the command we need to write. Yeah. After this, we can also import connect from nets. Now inside here we can say if there is no nets connection, meaning there is no like active connections available, then we can say await connect. We're going to connect our nets JetStream with the servers, which is going to be process.env.nets_url, or our nets and local host 4222. Yeah, and name, it's going to be, let's say, OML server. Yeah, after connecting, we can add here on console log that connected to nets. Yeah, and we can return this nets connection and the JSON codec. Yeah, that's it. Our index.ts is ready. After this, we have to create another file for producer. We could add that in here also, but it's better to add the producer in a different file so that later on we can easily modify the code. Here we can create another async function by giving name publish log batch, because it's going to publish the all logs. We can add here key ID, which is going to be the parameter, which is going to be a string, and logs, which type is going to be any, and server received at, very important, because based on this we can find out the latency. So received at, we can calculate the latency, not find out. And here we need to import few things from await get nuts. So get nuts, and we can import our nc and jc from here. Here we can say const js nc dot JetStream. Wait, why the nc does not exist on type nc any and jc codec unknown? All looks good. What's wrong in here? I don't know. We will check it later. Let's call the JetStream in here. Now await js.publish. We're going to publish it into logs ingest and jc.encode the JSON codec, encode the key ID, the server received at, the timestamp, which is going to be date dot now, and the logs. Yeah, now here it's giving the error. Let me check why it's giving the error. Get nets. Oh, nc and jc, nc here. Alright, the mistake is actually in here. I found it. We cannot return it like that. We have to return it outside from here, because this was inside this if block. It's definitely need to be outside from here. That's it. After taking it outside, you can see no error anywhere. Everything is perfectly working. Yeah, great. We can come back to our here again, and after the producer and like setting up Night's JetStream, what next? The next is we have to right now initialize the stream. So we can say init stream.ts, a new file, and inside here we can again export on async function by giving them something like init nats stream. And here we don't need any parameter. Here we can say const something from our get nuts here dot slash index, and here we can receive the nc, and we can say const jsm, the JetStream await nc, means the nut connections client, and we can call the JetStream manager. So JetStream manager. Now await jsm.streams dot add. We can pass the name in here, which is going to be oml, and logs. The subjects, it's going to be logs.ingest, and the retention, it's going to be work queue. It's basically like message will be deleted after the acknowledgement, the retention work queue meanings. And storage, it's going to be file, maximum age going to be 0, and maximum message is going to be -1. Yeah, we can add here another console log, that JetStream oml logs initialized. We can save it. Our init stream is also ready. Now the last one, or the most important one, is the consumer, or like the main function, which is going to do everything for us, the consumer.ts. Here we have to do a lot of work. We have to set up the consumer. Inside the consumer, we will like check for everything and we'll store the data one by one. But before the consumer, let's do one thing. Let's create the function in here and we will work here later. We can say export async function start logs consumer, and we can just call the function like this. Yeah, and we can import our get nets from index, and we need the nc and json codec, and we need our JetStream connections and JSM, the JetStream manager. Yeah, and we need our durable subject and stream name, because without that we cannot like connect with the producer, with this consumer. Like this is the consumer, so we need a durable name, the subject name, and the stream name. And we need the options, so we can say consumer options imported from nets, and options to durable. Let's pass this in the manual acknowledgement. We're going to manually acknowledge the data, and the acknowledge explicit and deliver to our OML logs worker. Yeah, that's it right now. For now it's fine because we have to set up nets and Kafka. We already did, but we have to set up in our Docker file. It's just Redis, and yeah, it's just Redis in here, but we have to set up Kafka and our, sorry, not Kafka, ClickHouse and Nets JetStream. So at first start for ClickHouse after this Redis. So on this level, yeah, we can say ClickHouse, and image. We're going to use here ClickHouse / ClickHouse server 25.7 Alpine, this image. For container name, we can say ClickHouse restart unless stopped, ports like 8123 and 8123, which is like the HTTP interface. And we also need our client native interface, so for that we can assign the port like 9000, so 9000. Yeah, and volumes we can say ClickHouse underscore data, and var lib ClickHouse. We have to pass some environment variable, so environment, yeah, I think correct spelling, environment. Yeah, we have to pass here our ClickHouse underscore db, which is going to be logs, our ClickHouse user, which is going to be default, ClickHouse password, which is going to be empty string, ClickHouse default access management, which is going to be 1, and u limits, yeah, no file 262144. It's basically a limit. We also need our ClickHouse UI. So ClickHouse UI meanings, with that we can see the database like value. This is just for development purpose so that we can check it out. Yeah, so here we can add another image like this. So CHUI, we just need another space in here, I guess, or wait. Yeah, we can add here image, our another space. Yep, gscr.io and something like this. You can also copy the name, it's basically a name, and CHUI latest, the ClickHouse UI latest, and it depends on ClickHouse it depends on ClickHouse. Environment, we need our ClickHouse URL. So we can say void ClickHouse URL, because here we have to pass the void ClickHouse URL, which is going to be HTTP host docker internal our 8123 port, then void ClickHouse user, which is going to be default, and the void ClickHouse pass empty string. Yeah, and ports 5521/TCP. This is on TCP port. That's all for our ClickHouse and ClickHouse UI. Now, after this, we need to set up Nets JetStream. So we can say Nets, but something like this. Yeah. Let's add the image for Nets. We're going to use here Nets 2.10 Alpine image, and container name is going to be OneMinute logs Nets restart unless stopped, ports 4222 and 4222. Yeah, this is like the client connections. And for the monitoring web, the UI 8222 volumes yeah, we can say nets underscore data and data like this. Then command, it's going to be net server JSM and 8222. That's the command. Yep. In volumes, let's add our ClickHouse underscore data and our nets underscore data. We can save it, and here we go. Our Docker setup for now, it's ready. It should be good enough. Let's write our Docker compose up -d. It's going to restart all of our image, Docker image. Let's come back here. Give on reload. Here you go. You can see our CHUI, the ClickHouse, Nats, Redis, everything is working. Now to get access to our ClickHouse UI, we just need to go to 8123 port. If I'm not wrong, let me see. Localhost 8123. Here you go. You can check the UI, and here from here we can go to dashboard. You can see the queries, CPU uses queries running, merge runnings, selected bytes, and everything from here. Okay, we can come back to dashboard again, or we can go to here. Yeah, and this is the WebSQL UI. Yeah, so from here you can basically write something, and this is the cloud, this is the merge visualizer and everything. For now it's fine. Let's come back here again. Since our Nets JetStream and our ClickHouse both are working properly, we can close all of this and we can start our next work or new module. So next work is basically setting up our npm SDK for OneMinute logs. Why the next work is setting up npm SDK? Because with that npm SDK, only with that npm SDK, you can send logs. Without sending the logs, we have nothing to do in our backend, right? After sending logs from the SDK, after that from our this backend, in these modules, we can start to work for logs module. And that logs module will call the producer. The producer will call this Nets consumer, and the consumer will process the log. So this is the setup. Right now, we will work for our npm SDK. So yeah, let's start to work for the npm SDK. All right, welcome back to our setting up SDK our OneMinute logs SDK module. From here, let's come back inside our SDKs folder, and inside here we can create our OneMinute logs -next npm SDK. After this, we can create here on src folder. Inside this src folder, we can create on index.ts, and inside this OneMinute logs -next, we can add our package.json, readme.md, and our git ignore. And that's it. For now, it's fine. And one more thing, very important, that is our tsconfig.json. Yeah, that's all for now. Now let's come back to our package.json. Inside here, let's add name for our package. It's going to be OneMinute logs /next, because it's for Next.js, that's why. And for the version, we're going to use here 1.0.0 for now. However, the npm library is already live, so here the version is 1.0.0 for development purpose, fine. When you're going to make it live, we must have to change it to the accurate version, because currently the OneMinute logs /next version is 1.0.2. so for production it's going to be something like this, but for now it's fine since we're going to run it in local development mode, that's why. For the description, we can add something like this, that a lightweight npm package for working with OneMinute logs, setting up your logging pipeline within OneMinute. Here for the type, we can say it's basically module, and after this we can add the main file, which is going to be dist/index.js. then types, it's also going to be dist/index.d.ts. files, we're gonna add the dist folder. Scripts, there is going to be build script. However, let me turn on the do not disturb mode. Here the build command is going to be tsc, the clean command is going to be rm-rf dist, and prepare for updating it or uploading it to npm. This is the command. It should be npm run clean and npm run build. After this, we can add the repository block. Inside here, type is going to be url. Type is going to be git. URL is going to be our basically the npm package URL, something like this. For you, definitely have to change it, because you cannot use the same repository URL because it's unique value. And keywords, something like this, that logs OneMinute stack. Then some other keywords, like we can add something like this, that structured logging, monitoring, observability, audit, and security. After this, we have to add our author name, so we should add here the name to our company name, which is OneMinute stack. The license is going to be ISC license, and bugs, for bugs, here is the bugs URL. If there any bug, then you can create an issue to the npm package, something like this. Sorry, to not the npm package, to the GitHub repository. Now home page, it's going to be our basically the documentation page. However, it's currently, if you click here, it's not going to work. You can see it's not working because the URL is not available. After after deploying it, it will be available. Now dev dependencies, type /node, and we need this version. We need our ts node library. We're gonna use this one. And TypeScript, this one. Yeah. After these, the dependencies, let's add React. This 19.2.7. Yeah, all good. After this, we can come back here again. We can clear it. We can go to our SDKs. Sorry, our SDKs like this, and our 1Minute logs next, and we can write on npm I to install all of these dependencies and dev dependencies. Now let's come back to our tsconfig.json. In here, let's add our compiler options. Out directory is going to be dist, and root directory is going to be actually source folder. So src module, our module is going to be node next. Target, it's going to be 2020, actually not 2025. Module regulations, it's going to be again node next. And es module interrupt, it's going to be actually true, not false. And declaration, it's going to be also true. Finally, in here we have to include our source folder. That's it. We can save it. Our tsconfig is also ready. After this, we can come back here. You can see there is an index.js, which is fine. We can delete that, but here this is our index.ts. And inside this src folder, let's start to work now. Let's create our configs folder and core mechanism and types folder, then one for utils. Yeah, that's it. Now in this configs folder, we can add our index.ts. So basically here we're gonna add our interface for env config. Here we can add on base URL, which is going to be string, then export const get env config. We can call the env config type in here. We can return our base URL from here, which is going to be http://localhost 8080/API/v1. Yeah, for now, something like this. We can save it. Our configs is ready. We can come back to our core. We can create here actually on index.ts. That's fine. And in this types, we need actually multiple types. First on index.ts. Secondly for log, so log.ts. Then for metrics, metrics.ts. For security, security.ts. And for tracking, so track.ts. Yeah, that's all. Now in this index.ts, at first let's do one thing. Let's start to work from this log, then we will finally start in this index.ts. So here basically this is our log interface. We can say export interface log timestamps, and it's going to have our event time, which is going to be string, and the ingest time, which is definitely optional, string, because the value is going to be set from backend. Now export interface log message, and type, which is going to be this log type. Now log type is not available here. We have to actually create our log type. We're going to create that in here. the log type is going to be something like this: export type log type. It's going to be error or warning or info or audit or metric or debug or success. Yeah, that's all. If you want, you can add some more types as well if you're feeling that, yeah, we should add anything more. Then we need another one for importance, something like this: importance. So export type importance: critical, high, medium, or low. Then another one for subsystem user role. And finally our auth status. So we make sure to add all of these type. Now come back to our, wait, I mistakenly added it in index.ts in core folder. No, we have to add it in these types, not in core. Yeah, now we can come back here, we can import our log type. Here we go. After the type, we need message, the log message, which is going to be string. The importance, which is going to be the importance. So importance, import the type from index.js. Subsystem, we make sure that this is JS, not TS. Okay, it's important because after building the project, our like Node.js, it doesn't understand TypeScript, it understands JS, JavaScript. So that's why we have to make the extension like this, .js. Then operation optional string track, it's going to be log track. So this is also something we have to create right now. So log track, it's basically here we can say export interface log track and user underscore ID string. Role is going to be user role. IP, the user IP, this is going to be auto-filled from the request basically. So IP string. User agent, same string. And geo, like the location, which is going to be string as well. Yeah, we can save it. After the track, we can import it. After track, we need security. So security, which is going to be log security. We have to actually create the log security. Let's come back to our security.ts and we can say export interface log security auth underscore status. It's going to have our auth status. So auth status from our index.js and the suspicious level. So suspicious, which is going to be Boolean. The tags, it's going to be an array of string. You can add like tags for your security object in here. So security type is going to be log security. After this metrics, so metrics is going to be log metrics. Now log metrics we have to create in our metrics. So log metrics, let's add our interface log metrics. We basically need the latency ms, which is going to be a number, and db query count, which is also going to be a number. We can save it, we can come back here again, we can import it. Then finally we need the timestamp, which is going to be log timestamps. This one, we can save it. So our log message type is ready. And not only that, our metric, security, track, all of these ready except this index.ts. Here we have to do some more work. Now in our index.ts, in this type, at first before this log type, we need to create our log level. It can be info or warning or error. Yeah. Then let's create another interface, that logger config, and API key, which is going to be string, app name, which is going to be also a string, environment, which is going to be string as well. After this, we're gonna add our log payload interface, like the log payload which we have to send. We have to send the log type, the message, which is going to be string as well, the importance, it's going to be actually optional, then subsystem, optional again, and we can import subsystem, operation, again optional, string, track, log track, security, log security, then our metrics. You might be thinking why we're adding a lot of types, because types is very important, because when like the developers are using our npm SDK, our npm SDK needs to give them suggestion like what they should do and what they should not do, because like for an npm SDK, types is very important. We cannot skip it at all. There's no scope to skip types for an npm SDK. So timestamp, it's going to be log timestamps. Now ingest state at, it's going to be number, and the app name, string, and the environment, string. You might be thinking how then I'm writing all of these types. So it's basically based on the like our ClickHouse schema, but on a extended version. Like this is the final version. This is how you can store your logs, all the types here. And in future, we will definitely extend it to more. Like there will be some more options in here, which I am at this moment, I'm not watching probably, but in the future it can happen that we need some more like fields. So we will definitely add that in the future, in like in the upcoming versions. That's it, our types ready. It was definitely not small, but it's done. Now in our core, we can come back here, and here basically we can create our function. So we can say export function, create logger, and config. We can call our logger config. We need to add here on transport. So transport is going to be new OML transport. So OML transport, what is the meaning of this? OML transport is basically coming from our utils folder. Let me show you. It's basically a class, nothing else. This utils we can add on index.ts, and here we can add our export class OML transport. There is going to be on base URL, like by default it's required. We need API key, we need our app name, we need our environment, we need headers, we need like the buffer value, we need the timer. So timer, and finally we need a flash interval, because we're not going to add all the logs instantly to our like backend. We're in here also, we are doing something. I'm explaining it after some time. At first let me import the log payload, and node.js.timeout is giving error because the types is not installed yet. However, this will not give error. Just a minute. Headers, base URL, declared but never read. Okay, fine. And it's flashing false. Now, it's basically like we're creating a new transport instance. With this logger configurations, we can basically we can queue all of the logs in a single time. For an example, it can happen in like every 5 seconds there. Let's say here, not actually 5 seconds. We're sending logs after every 2 seconds. We're like batching all the logs and sending that to our backend. It's very, very helpful. It's like another filter layer from our NPM SDK for organizing the logs, because logs are really a very messy thing. It can happen that we're receiving like thousands of logs in every minutes. So that's why we're basically adding that in a batch, so that like our API can again send that to our like message broker. This is definitely optional. This is not a mandatory thing, but we're just doing it to improve the scalability, we can say. That's it. Now here we can add on constructor. We can say private config, and we can call our logger config. And inside here we need to pass our env config. So env config, which is going to be the get env config, call it, then this dot base URL. It's going to be env config dot base URL. This dot API key is going to be again config dot API key. This dot app name, it's going to be config dot app name. And this dot environment, it's also going to be config dot environment. This dot headers, here we have to pass the content type, which is going to be application/JSON, and XOML API key. So actually X API key, not XOML API key. X API key, which is going to be config dot API key. Then we can spread the config dot API key, app name, or our actually it's fine. This is fine. Like empty object. It's basically we're setting in the headers, but we don't need to set up the app name inside the headers. We can send it through our body also, but I think for faster validation we need it somewhere, so we can set it XOML app name, which is going to be config dot app name. Here we have to add it inside the second bracket, otherwise another empty object. Yeah, after this, here actually not OML transport, we don't need that. That was the mistake. Yeah, another spread operator, and we don't need OML transport. Config dot environment XOML env config dot environment. See, I didn't delete that second bracket. Somehow it's automatically deleted itself. Yeah, now it's fine. After this, we can call this dot set up graceful shutdown. So this dot set up graceful shutdown. It's basically another module we have to create. We can create that in here. We can say private setup graceful shutdown. It's going to register the process level handlers. Yeah, we can say const shutdown handler async signal it's going to be string, and if this start shutting down, then return it. Otherwise this start shutting down, make it first true. Then we can add here a try catch statement, and the try part we can say await this dot flash flash. So flash is giving error because here the flash is missing, that's why. Actually I think for flashing, yeah, so because flashes is like the in-memory buffer to the server as a single batch, we are basically flashing the data. So let's do one thing, let's add a private module like flash. It's going to be actually async, and here we can say if this dot is flashing, then return, otherwise this dot is flashing, make it true. And if our this dot timer, then clear the timeout, pass the this dot timer. Wait, why like this, delete it, yeah. Then after this we can call this dot timer again, and we can make it null, yeah. After this we can add here our batch, so const batch this dot buffer dot splice 0, and this dot buffer dot length. And here we can say if our batch dot length equals to 0, then this dot is flashing, we can make it false and we can return it. Otherwise here we can add a try catch statement, which is the final statement, which is going to send this data. So this dot base URL slash send. So actually not slash send, the endpoint is going to be slash API slash v1 slash log slash send, yeah. And method is going to be post headers, our this dot headers, the body, which is going to be json dot stringify, the logs, and the batch, yeah. Now keep alive, make it true. Then if it's catch any error, then we can console log the error that OML transport flash failed, and then here we can call the is flashing and we can make it false, that yeah, flashing actually done. Yeah, now let's come back here again in our this setup, the setup graceful shutdown in here. After this dot flash here, if it's catch any error, we can console log the error. Let's do one thing, console error the error message that flash during shutdown failed. And finally we can call our process dot exit and we can make it 0. So this is giving an warning because we have to install our types node. So npm I types slash node, if we install it, I think the warning will be gone. You can also see it in here. Yeah, the warning should be gone. And it's saying add node in the types. Then add note to the types field in our TS config. We can say node, come back here, and here you go. No error right now. After this, we can say process.on before exit. We can call the shutdown handler and we can pass the before exit in here. And process.on the sign int. We can call again the shutdown handler and we can pass this sign int. Yeah. After this, next one is, this is the last one, process.on. This is for site term and shutdown handler and pass this. Yeah, all done. I know it sounds a bit weird what we're doing. It's basically like we're working with a node handler. That's why it's looking a little bit weird. And you don't need to understand all of these. Some here might be a little bit different and complicated for you, but fine, you can use it. After this, after this setup graceful shutdown, one important thing you have to understand in here that like when we are making this npm SDK, we're not making it for front end at this time because you're not going to store logs from front end, right? You're definitely going to do it from the backend side. That's why we're doing it. Like we're sending the request from here because this is going to be like publicly. So like the developers who are using our applications, this npm SDK, especially this part, they're going to use it like from backend side, not from the front end side. Yeah, now it's not definitely done yet. This is our just like the setup grace shutdown. Now after this here, after this, what we have to do, we have to create our send with payload is going to be actually log payload. Yeah, now inside here, this is basically queue a single log payload for sending. That's it. If this dot shutting down is true, then return. It's basically going to ignore the new logs during the shutdown. And then this dot buffer dot push, which is going to spread the payload, the all payload, and it's going to add the ingested add with the new date dot now. Yeah, that's it. And after this, it's going to remove the like flash size. So if this dot timer is not here, then this dot timer, let's call the set timeout, and this dot flash and this dot flash interval. Yeah, all right, all actually ready. Flash is also ready. Now let me see if anything else missing or not. So for getting the logs, we haven't set it up yet because we don't have to do yet. We're still not like storing the logs, so there's no need to set up the logs right now. But in this constructor config and everything, okay, it's fine. But API key and app name and environment, these three things are not used yet. So here, this start API key, we already used it. App name same and environment same. Here also okay. Makes sense. All makes sense. So it's basically giving some error, which is very natural because the API key, app name, and environment, we're going to also use it in the get method, which we haven't created yet, which we will do after some time. After we're storing logs, then we will work for that like SSE streaming and also the get logs. So yeah, this basically the main file in here, not main file, the OML transport is ready. We can come back to our core again, and from here we can finish this. So it's going to receive the OML transport. We're going to call here, and we have to pass the config in here. Now we have to sense the log payload. So we can say const send async payload is going to be log payload. Here const something from the payload. We're going to receive the type, which is going to be info, then message, then importance, and subsystem. Like this is the default value. Okay, operation, service, and track, security, metrics, timestamps, app name, and environment, all we're receiving from payload. Then we can make a final payload. So final payload, which is going to be also the log payload. Type message, our importance, then subsystem, then operation, service, track, our metrics, the timestamps, and the app name. App name is going to be app name or config.app name or default if it's empty. Then environment or config.environment or process.env.node env. Like by default we're going to take it. Otherwise, if there is nothing, then development. Yeah. Then here we can call our transport and the send method, and we can pass this final payload. Yeah. Then after this, we need to create our type method, like log type, which type is going to be this. Then payload, we're gonna omit here our log payload and the type, and we can call the send, the payload, and type. Yeah, this is our type method. Now we have to return all of this. So return send info. We can say create type method info, the error, create type method and error, metric, create type method and metric, then audit, create type method and audit. Warning, it's going to be create type method and warning. Yeah, and the get, like the function, it's going to receive the filters, which type is going to be record, string, and any, and transport.get the filters. Yeah, so transport.get here all looks good, but transport is here. Okay, because the gauge is missing still, that's why. That's why the error is here. For now, let's comment it. We still have another one, which is stream, but it will also not work because we don't have it yet. That's why. Filters, sem record string, and any the transport dot stream, and we're gonna pass the filters as well in here. But let's comment it for now because we will uncomment it when we will have like logs inside our ClickHouse database, and then we can like create endpoint for get and stream, and then we can uncomment it and finish this part, finish this SDK actually. That's it. Create logger is also ready. It's not definitely bigger. Main work is in the utils. For now, everything is ready. We can come back to our index.ts, this source index.ts, and we can export everything from here, like the create logger from our /core/index.js, the create logger, something like this, then get logs. Sorry, it's not available yet, but we have the OML transport, something like this, but let's add it in here. No import, it should be export. Then we need to export the type from our basically the ./types and our index.js. Yeah, the types we have to export. It's going to be the logger config, the log payload, and the log level. Yeah, we can save it for now. For now, it's actually ready. So our SDK is for now fully perfect. We can come back here. You can clear everything. We can write this, that npm run build. Here you go. It's created a new dist folder and everything is in here. It's fully ready-made code. For now, it's fine, but definitely we're going to use here on another library, and that library is called, I forgot the name actually. It's for like converting all of this folder into one file, and that's very, very important, so that like no one can understand what's going on in the npm SDK. You cannot read the code base, which is very good for security reason, and we will definitely do that. But for now, our npm SDK is ready and it's actually going to work. So the next step should be for us here, actually no get ignore. Why? Let's set it up, the get ignore. I'm basically going to copy it. You can also check it slowly. Node modules, no npm debug, no yarn debug, or pnpm, then leave build source, no source. Yeah, we're not going to like we're not going to add this src folder into our GitHub. We're just going to send this dist folder, no env, no VS Code or anything like that. You can just check. Yeah, that's it. Git ignore is ready, and for the readme, we're gonna add that later because we still haven't finished the npm library yet. That's why. So since it's ready, we can right now make the backend, and after that we can try to use this npm SDK for sending logs. So yeah, let's start our next module right now. All right, let's come back in our services folder again. And in this source folder, in this modules folder, we can create our logs folder right now. And in here, we can say logs.controller.ts, logs.module.ts, and logs.service.ts. Yeah, and then we can start to work inside this. First, we can start to work in our logs module, which is going to be very simple. We're going to use that module decorator again in here, and controllers for now empty array, services, sorry, providers, not services, which is going to be empty array. And finally, we have to export our logs module class. Yeah, we can save it. We can come back to the controller. We can use here our controller decorator, and inside this we can add logs, We can use here guards, so use guards and AuthGuard. Export class logs controller. Class. So after this, in here we need a constructor. We can say private read only logs service and log service. No problem. We will create the log service right now. So let's come back in our service and use our injectable decorator, injectable, and export our class log service, actually log service, and constructor, keep it empty, and async send logs. We're gonna basically receive here body and the key ID. Body is going to be any and key ID is going to be string. Yeah, now we can come back again in here. We can import our log service, and after this we can add our first endpoint, which is going to be post endpoint for sending the logs. We can say async send logs, the request decorator, request type is going to be any. We need the body access, body from this just common, and body any, so we actually don't need this in here. Yeah, and here it should be a comma. Inside this we can return this dot log service dot send logs, the body, and request dot user dot key ID. Yeah, we can save it. All good in here. Now one thing very important, since we're sending the raw body in here right now, the JSON stringify body, we have to come back to our main.ts again, and the body process should be true right now, because if it's false, it's not going to work actually. So we make sure to go to the main.ts file again inside services and make the body parser true. Yeah, now we can come back in the send logs, because we're gonna receive the logs in here. From here we can say that we can basically call our publish log batch. We can pass the key ID, the logs. The logs is going to be basically body dot logs, and the server received at time. So server received at time is going to be like the date dot now when it's receiving in here in our like service. Then after this we can send like we can publish the log. That's what this is, it's supposed to do. And then we can return that message. Okay, yeah, that's it. Yeah, very simple and small, because the rest of the work this publish log batch is going to do, because it's going to right now publish it into our consumer, and the consumer is right now going to do the rest of the work, which we will do. But first we have to come back to our app module, and we have to add our logs module. We can add in logs module, let's add the logs controller and logs service. Yeah, great, everything is perfect. Now we can come back to our publish log batch, and from here we are basically calling our this consumer, and we have to start to work mainly in this consumer right now. Basically we're going to process the log from here. So from here, from this consumer, after this we can basically add on try catch statement. We can check for the existing like JSM, the JetStream consumers, the existing consumers info. we have to pass the stream name and the durable, then const cfg, which type is going to be any, and existing as any dot config. If config means cfg, and if config dot deliver subject is not available, then we can add in console dot actually warning that JetStream durable is pool based, missing deliver subject, recreation as push consumer. After this, if it's missing, then jsm.consumer dot delete, actually consumers dot delete. We have to pass the stream name and the durable. Yeah, if it's catch any error, then it's basically the 404 not found. We can proceed it to create, so we can keep it empty for now. We can say const sub await js dot subscribe. We can pass the subject and the options, and we can add in console log that oml logs consumer started. Yeah, now after starting, we have to write on for loop for all the message of the sub. So const message of sub, we can add here a try catch statement. We can say const data JStream, sorry, JSON encoded dot decode message dot data okay, and data basically okay, I think it's fine. After this, const key id and logs and the server received add. We are going to receive this from data, and we can say data as any. Now const now date dot now. So this date dot now and the server received at date dot now, this like in between time is the latency. And meta, we can use our Redis right now. So Redis, we need our Redis client. So basically the problem is that Redis, we already do have our Redis client, but that's inside this module. But in our net, since it's not a Nest.js service, we cannot import that global module inside here directly. If we want to do that, we have to also make it another injectable service. But we don't want to do it right now. We can do one thing to just like for this file. This is like on shortcut we can again say constant Redis and new Redis, and we can pass here the host, which is going to be basically our Redis host. We can say process.env.redis host. For the port, same process.env.redis port. And we also need the Redis password and DB. So password, we can copy this and copy from here as well. Next one is the DB. Just copy this, paste it in here, and Redis DB. Yeah, what it's saying. Okay, 1 minute. After this, we need our max retries per request, which is going to be 5. Then reconnect on error. We can basically like show the error message, something like this. And then the retry strategy times What's is giving this error that Redis DB? Okay, 1 minute. Let's comment that and let's come here and times. We're basically doing a back off, like after every 10 seconds, try and retry to connect the DB again. Yeah, it's fine, but Redis is giving on a warning. We don't need AI to fix it. Let's do one thing. Let's uncomment it or add DB. Okay, I understand why it's giving the warning, because it can happen that this is null. That's why. I think so. Or what's the problem in here? Okay, we have to pass host DB password. No. What's wrong in here? Actually, it's a number. That's the problem. So we have to say 0, because it should be a number. And same for Redis port. Let's do one thing. Let's cut this. We can say 6379. Here we can put it in a number. Okay, so this was basically the type warning, and same for our DB. We can cut it and add it in a number, something like this, and we can save it. You can see right now no error or nothing is wrong in here. Yeah, everything makes sense. Now we can come back here. We can start to work with Redis since we have right now access to our Redis DB. We can say get all our OML and key meta, the version, which is basically the version is version 1. And after this, we can pass the key ID. Yeah. So this is for fetching the metadata. Yeah. And after fetching metadata, we can say if the meta doesn't have any key ID. Actually, key ID was that. I forgot it. Fine. For now, it's fine. We can add here organization. Sorry, not organization ID. We're not having organization ID for the version 1. So user ID, we can say meta dot user underscore ID. And we have to right now transform the logs. So we can say const transformed logs dot map log any, and const now date dot now. After this, we need our latency. So latency value, it's going to be now minus the server received at, and Redis, we can use L push, and the ingest latency. This is basically for our dashboard value. So latency we can pass here, and Redis dot L trim, the ingest latency, another one. This is for 0 to 59. Yeah, like an average latency. Then const ts, which is going to be log time stamps and event time. If it's available, then date dot new date, and we can pass log dot timestamps dot event time dot get time function. Yeah, otherwise date dot now, this is not function, this was a method. However, fine. After this date dot now, after the ts, we need to convert our timestamp seconds to milliseconds, because ClickHouse date time is milliseconds, in milliseconds format. So we can say timestamp seconds. When use math.floor, the TS divided by 1000, we will get milliseconds to seconds, like the seconds value. Then we can return our key ID, then user ID, type, which is going to be log.type, the message, log.message, then service, log.service, app name, log.app name, environment, log.environment, and importance, log.importance, subsystem, log.subsystem. Yeah, next one is our operation. So 1 minute in here, log subsystem, since it's optional, we can say this or either null. Now for the importance level, we have to right now use here an helper function, something like this, that to importance, and we have to pass this log importance in here. So it's basically an helper function. We can create it in here. We can say function to importance. It's going to receive the input, which type is going to be actually unknown, number or null. It can be actually any, not unknown. Yeah. Then inside this, we can say if type of the input equals to number, then return the input. If our type of input is string, then const v, the importance, map, we have to pass the input dot to lowercase, and then we can return the v or null, or we can return normally null. Yeah, importance map, it's basically an object. Type is going to be something like this, like critical meanings. From our, like the SDK, we are having critical, high, medium, low value. So we are basically changing it to number right now. High means 3, mediums means 2, low means 1. Yeah, that's it. After this, after operation, we can track, we can add the track, that log.track or JSON.stringify. If it's available, then make it JSON.stringify, otherwise null. Same for security, same for metrics, and for timestamp, it should be the timestamp seconds. Yeah. Now the next step is we have to insert all of this into ClickHouse. So we can say await ClickHouse.insert. The table is going to be logs and events. Values is going to be the transformed value. Format, it's going to be JSON each row. Yeah. After this, we have to like acknowledge the message, we can say. There is definitely some more work. We can add some to do in here. We have to check, or we have to check the users accumulate. We have to accumulate the users, and we have to update the users, which we will do later on. And we have to broadcast the live logs from here directly. And then we can acknowledge the message. After acknowledging the message, we can say if the now and last backlog update. So this backlog update is basically like late variable. In here we can add something like this, that's 0. So if now and last backlog update is actually more than 1000, meaning we are basically updating our JetStream backlog once per second. We can say last backlog update now const info our JSM consumers info. We have to pass the stream name and the variable and the backlog. We can set info as any and num pending, so the number of pending info, or info as any num acknowledge pending. So num pending and num acknowledge pending, it's different definitely. And another one, info, we can set this time num acknowledge pending. So basically we are adding here all the possible backlog value. It can happen that info as num pending, or let's say num acknowledge pending, or num ack pending, like this. Yeah. After this we have to call redis.set, and we have to set the ingest backlog with this backlog value, that how many logs still in like we're ingesting, how many logs still are in like backlog. If it's catch any error, we can console.error the message that consumer error, and we can check the error from here. That's it. Our consumer is actually ready right now. It's going to store the logs into our database. How can we check it that it's working or not? No problem. Let's come back to our main dashboard. Before that, let's come back to our SDK. In our TS config, we have to do some modifications. We make sure that you are adding this include like this. Include cannot be on the source. We have to add something like this, otherwise it's not going to work properly. Yeah, after that, let's come back to our SDK. We can clear it. We can write this npm run build npm link and the name OneMinute log/next. We can come back to our main dashboard, stop it. We can again say npm link OneMinute logs next. We can clear everything. We can write npm run dev. Here we go. Now to check it or to test it, one more thing in app module. Okay, logs module is already there, so everything should work right now. Now let's come back to our apps main dashboard. In this lib folder, let's create our logs.ts, and we have to check the documentation. I mean, our documentation, we still don't have it, but I know how to set up OneMinute logs perfectly. I already like made this application earlier, so I know how to set up. You have to basically write this code snippet, and no worries, you will find out it on the documentation. So here we need our OneMinute logs API key, so we make sure that you are coming to your env and adding it in here. I'm in the example because I can't show you the .env, but for me actually it's already ready. And after that, sorry, somehow I came outside. Yeah, after that, app name is going to be, let's say, Becodemy. It's optional, but it's fine to add this. And node.env, it's fine, we can keep it development. Yeah. Now let's try to add some logs. So we can create an API in here. Let's say test actually test. Yeah, we can add here on route.ts. We can say export function, something like our 1 minute, something like we can say export async function. We should not say post because we're just going to test it. We don't need to receive anything. We're gonna just say await logs or log or whatever, logger actually, logger dot error. We can add the message that something went wrong. And now importance, we can say medium. Then like app name, we already have an app name, so we don't need to add that. We can add anything else. Let's think about it. What are the options in here? You can see these are the options. Service, we can say something just for testing purpose, definitely. Service, let's say testing. Yeah, we can do one thing. We can cut it. We can add here on try catch statement on the try part. We can add this on the catch. We can console log the error, and from here we should definitely send a next response dot next response dot JSON success true. Yeah, that's it. Now what will happen? One thing again, be make sure that you're having your OneMinute logs API key. If you're not having it, just come here, create a new one as already in the test. So come here, create a new one from here, copy that, add it in your .env, and then come back here, go to /test. Sorry, not /test, /API/test. Let's come back here. Oh, that should be error actually, because on the first time, no one should like fix. I mean, it's natural. We're not going to store it properly. It's giving a NATS error 503. Okay, we have to check it why it's giving a NATS error. Alright, so I find out why all of those errors were coming. First of all, in here, in our producer, in our NATS producer, it should be logs ingest, not log ingest. Because when we are creating the subject, you can see the name is actually, sorry, in here, the name is logs ingest, the subject name. So when we are producing the message, it must need to be the same name. So be make sure that you are also having here logs ingest. This is the first fix. Second fix, we have to come back to our schema, in our ClickHouse schema. Here we are saying that everything is like create on ClickHouse command, but we have to create on table. When there is no table available, we must have to create on table. So we can add here another comment. Another command that await ClickHouse dot command and query. We can say create database if not exists logs. Very important, this line. Okay, we make sure that you're adding this line. After this, most important work is our inside this main.ts file, because basically we have to set up Nets JetStream, we set up ClickHouse, everything, but we didn't call it here. We have to call it. For an example, here we can say await init Nets JetStream, and that's it actually for now. I think it should be good enough. We can save it. Now if we come back here, if we give on reload, the like the logs should be inside the database. Just wait a little bit, come back here. We have to write here on command to check it. The command is something like this, that select everything from logs.event, limit is 100. So there are no message here, because I think here in this init net stream. Alright, I find out the mistake. The mistake is in this line, this await net stream. we have to add this line instead that starts our log consumer. We don't have to initialize the net stream in here. If we add this and if we save it, you can see connected to nets and OML log consumer started. Right now, if we hit run, you can see there are already 3 logs because we tried it to store for 3 times. Right now, if we come back here and give on reload, you can notice there will be actually 4. You can see logs uploaded to DB. If we run again, 4 logs in here. And here is the type, message, app name and everything. However, the user ID is somehow missing. Why? I don't know. Let me see why it's missing. So user ID missing, user ID, it's underscore ID, but I don't think we're adding it as underscore ID. Let me check again from our, wait, we're not adding the user ID, we're adding the key ID. So user ID is meta.user_id. From the key ID, let me do one thing. If we console log the meta, we will probably get the value, but if I'm not wrong, it should be actually user ID. So let's try again. So meta is empty object, so that's why it's not working. It's basically OML key meta, this version and a key ID. We are using this for getting the user ID. However, we don't need this actually. We can get the user ID without even that. User ID, we can receive it in here if we want, like this user ID. We can save it and here the user ID. Let's do one thing. Let's come back to our logs controller. From here, let's send our request.user.id as well. And here we're gonna receive the user ID. We can say string. Nets producer, no. Something like this, yeah. So here, key ID, server recipient, wait, user ID we have to pass. So we will pass here user ID after key ID, which is going to be string. And here we can pass the user ID. Now in our consumer, it's going to receive the user ID like this, and yeah, we're storing it. So if we come back here, if we give on reload, come here, hit run, here we go. This time you can see the user ID is in here. So we are getting the user ID and everything, which is very important for us. Now you might be thinking, how then we can delete it? Since this is ClickHouse, you don't have access to like traditional database like that, especially in local server. We can do one thing. We can actually truncate. I forgot the command. I have to check actually documentation. Yeah, it's something like this. The truncate table logs event. Here you go. Nothing is available now. Even if you run it, you can see it's empty completely. If you give on reload, here we go. There will be one error. Yeah, you can see one message in here. If you give another reload and hit run, yeah, 2 rows. So it's actually working perfectly as we expected. And yeah, app name, Becodemy, environment development, the message, the type and everything. Now what next? This was just for testing purpose, that is it working properly or not. And the interesting thing is that we were using our 1-minute logs library throughout this, right? We were using our 1-minute logs library inside our this main dashboard, right? We're testing it with our logger, and logger is coming from here. So everything is working. Right now it's time for broadcasting the logs from this live logs. So we can make that. At first we will finish the backend and then we will start to work for the npm SDK and we'll finish it. So let's come back to our logs service, and from here we can start to work for it. All right, after this async send logs, we can create here a new function or new module. We can say start SSE, meaning start the server-side events, server-sent events actually. It's going to receive a request. It's very, very important because we need access into that. Or wait, let me see. Actually, we need access into that. And response, we also need access into that. So response, we can give it type to any, and that's all. We need access. After this, we can write our user ID, which is going to be request.user ID. Let's extract our user ID from here. After this, we need our limit, like how many data we can send from here. So we can say request.query query dot limit, or by default 500, and const type request dot query dot type as string or undefined, const env request dot query dot env as string or undefined. Then we also need the app name, again as a query, request.query dot app name as string, or it can be undefined as well. Same for the search value, so we can say search request.query dot search search as string or undefined. Now we need to set up the SSE header, so we can say res dot set header. However, set header option is not coming here because we have to use here express response or nest response. I think we're using here wrong response. Let's do one thing. Let's copy the name. Let's come back here and let's say import response from actually express. Yeah, right now you can see we have our set res.set header right now, and here we can say content type, and we can set the content type to text/event stream. You can see it's different. It's not that normal content type we set like application slash JSON. It's not like that. It's text/event stream because it's an event stream. It's not a normal response. And we have to set actually some more headers as well, like cache control. We have to must make it no cache. No cache. Same for our connection. So res.set header connection, we have to keep it alive, so we can say keep alive. After this, we have to flush the headers, just call it, yeah. And then we have to make on conditions for our ClickHouse queries. We can say conditions, and here the user ID is going to be the user ID, and it's going to be actually string, yeah, but we don't need this because we're actually going to use it as a condition. Then we can say if our type, then conditions dot push, we're gonna push the type, and type is going to be string like this. S must need to be capital, we make sure this. And if there is env, then conditions dot push environment, we have to push the environment in here, environment, and env string, yeah. After this, if there is app name, then conditions dot push app name, and app name is going to be string as well. After this, we can say if search, then conditions dot push and message I like, and here we have to say search, which is going to be string as well. Yeah, that's it. Now we have to build the query command, the SQL command. It's going to be something like this: select everything from logs.events table where the conditions dot joined it with and, something like this, then order by timestamp the descending way, and limit, let's keep it limit u integer 32. Yeah, that's it. After this, let's run the real query. We can call ClickHouse dot query, and here we have to pass the query. Format is going to be JSON each row, and query params, it's going to be organization, sorry, not organization ID, user ID, type env, app name, search, and limit. Yeah, that's it. Then const initial rows, it's going to be the await rs.json, and then we have to write the response. So we can say res.write and data. Let's call json.stringify, and type is going to be initial logs, which is going to be the initial rows dot reverse. So we are basically reversing it, and then we can add this, that /n, like /n and /n, and then we have to call here on helper function called add client, which is basically going to add this as a client, and user ID we have to pass here type env, app name, and search. Let's create this add client. So we can come back here, the source folder, we can create a new folder by giving them sse. Inside here we can say sse registry, so it's basically we're registering the sse in here. And here for the add client, let's add our add client. So export function add client, it's going to receive the res, which is going to be response, and the filters, which is a interface. So let's add our filter interface in here. Let's come back here, let's say export interface the filters. Here we can say user ID, which is going to be string, type string, env optional string, app name string, and search same string. Yeah, now we can come inside, and for the response we have to actually import response from Express library. Yeah, we can come back here, we can call the add client from here, and there you go, no error right now. Now inside this add client we have to call clients variable, which we have to create now. So let's call the clients variable, which type is going to be sse client, an empty array. So sse client is basically another interface. We can say export interface SSE client and race, it's going to be response, filters, the filters, that's it. That's our clients. Now here we can say clients dot push and push the race and the filters. That's all. We can save it now. I think there should not be an error. Yeah, there's no error. Now after the add client, we have to call the request dot on and we have to close the request, add here on callback, and then raise dot send from here. All good. Now we can copy this start SEC. We can come back here. We can say get from nest common. The endpoint is going to be something like stream, the get endpoint, and here after this we can say async start SSE. We need the request. So request, which type is going to be any. Here we don't need anything here. And we need res, which type is going to be actually response from express. That's it. And let's call it, yeah. And let's pass it in here. So res, and we can import res from there, and response from express, what it's saying. Quick fix. Okay, express.response now makes sense. Yeah, fine. Now here we can return and call this .log service .start SSE. We have to pass the request and the response, I guess. Yeah, that's all. And then rest of the work, the SSE start SSE, it's going to do by itself. Exactly, because from here we're already writing the response. All good. Our backend side is actually ready for now, but one more thing, very important, from our consumer. This is for like fetching the data, but for real-time data, when we are like adding the data or storing the data inside our consumer, after storing this, you can see here we said broadcast live logs. So we have to actually right now call that function. It's going to broadcast the live logs from here. We can come here, we can remove this. We can say broadcast logs. It's a new function and we have to pass the transformed in here. So broadcast logs, let's copy the name, come back in our SS registry again, SSE registry, and we're going to create the function in here, export function, broadcast logs. It's going to receive the new logs, which type is going to be any. We can save it, we can come back here, we can import it. There you go. Now inside here, we have to deliver the logs one by one or in chunks of 50. So we can say const chunk size, which is going to be 50. Then since it's an array, so we can write on for loop. So for const race and filters of the clients, we have to look for the matched log, because we don't want to add same logs for multiple times, like twice or multiple times. So we have to filter it. We can filter out with the like new logs to avoid that mutating the colors array. Then we have to reverse, so reverse, and then we can write the filter logic, filter, let's say log, and if the log dot user ID is not matching with our filters dot user ID, then return false. Copy this, and this time if the filters dot type and our log dot type log dot type is not matching with filters dot type, then return false. Yeah, we can copy this, we can come back here. This one for E and V, so E and V, E and V, and E and V. not env, it's a mistake. It should be environment, as we are adding the value like that, environment, and this one env. Fine. Now we can copy this one is for app name, so app name, here app name, and here as well the app name. Yeah. Now this one is for search, so search, we can call the search. Now this one is a little bit different. Let's delete this, and we can say, and if the log dot messages dot includes the filters dot search, then like return false. Yeah, otherwise return true, like for normal logs. Yeah. Now here we can say if our match dot length is 0, then continue the function, so continue, otherwise break the match logs. So for let I equals to 0, then if the I is more than the matched dot length, sorry, less than, then what we have to do, we have to add it into our chunk size, and then we have to slice it. So const slice the match dot slice I plus chunk size. Yeah, and we have to write it as response. So raise dot write data JSON dot stringify, and type, which is going to be actually live. Yeah, and the logs itself in here we can say slice, and then after this we can add /n/n. That's all. We can save it right now. We can come back here. All still looks good. So consumer is also working perfectly. The uses accumulate, which is still not possible because we have to work with the billing mechanism. Then it's possible. So we will do it later on. And we don't need the console log anymore at this time because everything is working. So we don't need that one to check it. After uploading logs to our database, we were basically console logging in there. But we don't need that since everything is working properly right now. All good. What we can do now, since our backend is actually ready, it's definitely not fully ready yet. We have some others like function or other module we can say, like for this is for broadcasting the logs live. Sorry, not here, I mean here, this SSC. We have also another function, another module for parsing the filters and basically like running the logs. I mean, you can do a query to get the logs. So let's add that right now. Then we can like, we don't need to come back again. We can finish it at the same time. So we can say async get logs. It's also going to receive the request and response, but since this is not any server send events, we don't need a response in here. We can just return it. But for get logs, we probably need the request access. Actually we need. So for now we can come here and we can say const user id, which is going to be the request.user.id, and after this we can say const parsed. So parsed, we have to parse the field, the filters, not the field, because for searching logs, definitely you're adding some filters. So we are going to parse the filters from your language to our like understandable language, we can say. Here we need to make on private async module that parse filters, which is going to receive the query object, which type is going to be any. Then we can say const filters. We can set here on limit, which is going to be number, type, which is going to be string, and all of them are actually like optional because it can happen, or it can happen that it's not like inside the query, because it like all of them are optional, that's why. So search, which is going to be string, and the range, same string, and by default an empty object. Now we need the raw request, the raw query data. So query object dot query as string or undefined. If raw, then we can check the parts. So we can say parts, then raw dot split on regex pattern, something like this. It's basically for looking for the and s, and we can use here on plus and something like this, and you can see it's going to basically check the query. Like you can write query something like this, that type error env, let's say development. So these are basically the normal queries which you can write. Let's say app name, like Becodemy. So you can set up your queries like this, and then we're checking the parts from here. Now we can write here in for loop for const p of parts and const k and v, then p dot split. We're going to removing all of this. I don't know this sign, I forgot usually this name. So if there is no key or no v, actually it should be opposite. If there is v and if it's undefined, actually, then continue. Yeah, continue. And otherwise const key that k dot trim, and for the value const v or value we can say, then v dot trim. Yeah, if our key equals to type, then filters dot type val, like this. Else if our the key equals to env, then or very, very important, or if our key equals to environment, then filters dot env is going to be the val, but it should be actually outside. Oh shit, yeah, like this, filters dot env, which is going to be the val. We can copy the else if, and here we can change it to app, or let's say app name. There can be two names, so that's why we are basically adding these filters. And filters dot app name, which is going to be the value. Yeah, let's add again, and this time for search. So search, and actually only search, so we don't need to add it for twice. And filters dot search value, we can again copy it, and this time it's for range, and it's actually same everywhere, so we can say range. And next one is for limit, so it's also should be limit, but here we have to change it to number because the type is only number. Yeah, that's it. It's actually ready. However, what is this? This is actually the for loop. Yeah, so we can come back here and we can add this, that if query object dot type, then filters dot type string, and the query object dot type, we're basically setting up to the correct type right now. We can copy it again, and this time it should be for the env. So env, and yeah, it should be also a string, so env. Same for the app name, so app name and app name. And this one is for search, so search and search. Next one is for range, so range and range. And last one is for limit, so limit and limit. Filters dot limit, it should be actually number. Yeah, then returns the filters. We can save it. Now we need some like variable, some default variable like maximum limit for the query. It should be 500, not more than that. I think we're already having the maximum query somewhere. Oh, we're actually inside, that's why the error is here. We can cut this and we can actually parse filters, this dot parse filters, yeah, because this is a private module inside this. However, let's come back here and we can do one thing. We can come back to our configs. Here we can say export the max limit, something like this. We can save it. We can come back here again and we need our query cooldown. Basically, we're using here on caching mechanism. It's important. Why? The important is because, like, think about it, in like SSE, it's fine. It's not, there's not any problem of spamming, or sorry, I'm consumer. I should be in this service. Yeah. In start SSE, there's no problem of scaling because we're already limiting here. But for our query, there is scaling problem. It can happen that someone like doing spamming, let's say running on for loop on our queries. So our server will crash because of that, because that's a lot of query requests which are not true. So that's why we are basically making some caching mechanism for those queries so that we can prevent like the crashing problem. I mean, we can speed up the query more fast. And for that reason, we have to make on query, sorry, we have to make on caching mechanism. So we're gonna do that. Let's come here and actually let's come outside, I guess. Yeah, we have to actually come outside and we can say const query cooldown and new LRU cache. We're gonna use our LRU cache. This is the fastest, and number, string and number, the type. So we are gonna add here a maximum number, which is going to be 50,000. 50,000 not 5 million, but 500k actually. Yeah, 50,000. And let's add our result cache in here, result cache, which is going to be new LRU cache and string, and the rows type is going to be like any, the total count, which is going to be number, and the TS, it's going to be number as well. Yeah, then here we can add the max, which is going to be 20,000. Yeah, all good. And we need another private module in here. After this, we can say private async build cache key, which is going to receive the user ID, which is going to be string, and the filters, which is any. So basically, for same type of filter, we're making it cache. That's the secret in here. User ID and JSON.stringify the filters. Yeah, and we also need another function for cooling down. So is cooling down, and it's for user ID. So we are basically limiting on user from sending multiple, like let's say on spamming amount of request from one ID. So we can say date dot now const last query cooldown dot get. We can pass the user ID. If the last and now minus last more than 2000 milliseconds, then return true. Yeah, then what we have to do, query cooldown dot set the user ID and now, then we can return false. Yeah, That's it. Now here we can come back after this parsed. Let's add a limit, let limit, which is going to be parse.limit, or if it's not available, then by default we're gonna think it 100. Yeah, if the limit is less than the max limit, then the limit should be max limit. If the limit is more than 1, then limit should be 1. Yeah. Now we have to add the timestamp filter. So we can say let timestamp from, this is basically for those like filters, like you were saying last 1 week logs or last 3 days logs. So we have to transfer it to the real format. So like the timestamp from to timestamp to, so number or undefined. If our first dot range, then const match first dot range dot match. We have to use basically here an regex pattern again, something like this. Looks a bit weird, and regex patterns always looks weird, so no worries. You don't have to write it. You can just check it by yourself and actually have to write it if you're not having the source code. If you're having the source code, then just copy it. But still I'm writing it. It's really hard to write regex pattern like this. Yeah, but yeah, it's done. We can say if the match, if there is something with this pattern, then const value, we can call number, and the match and the first index, second index, not the first. Not index the second value from the array, which logical index. So unit, which is going to be the third one. Now second, math.floor date dot now. We have to divide it with 1000 and we'll basically get the seconds from the milliseconds. Now we can say const seconds. The s is going to be value, m going to be value multiply 60, h is going to be value multiply 3600, and d the value multiply, it's basically second, minutes, hour and day. We're converting into seconds. Yeah, and the unit. Perfect. After this we can say the timestamp from equals to now second minus the seconds, and timestamp to the now second. So we basically changed the format so that our query can understand it easily. Now if the first dot from, then const if, we can call number first dot from, and timestamp from, if it's like less than this 2e12, it means if milliseconds, then convert to seconds. Then math dot floor f divided by 1000, or the f itself. Yeah. Then we have to come outside and we have to say if the parsed dot to, then const t, call the number parsed dot to, and timestamp to t, then 2e12, and math.floor, it's basically a pattern which is like checking if it's milliseconds or not. Here we can say math.floor t divided by 1000, or the t itself. T means nothing, that true shortcut form. Okay, f means from. After this we have to check for basically like if there is no timestamp from or no timestamp to, then by default we will make it 30. Then we have to make it 30 by default. So we can say now second math.floor date.now divided by 1000. Then timestamp 2, we can set this now second, and timestamp from now second minus 30. Then we can multiply it with 86,400, which is 30 days into seconds format, this one. Yeah, and finally we can extract this type env app name and search from our parsed. Yeah. Now for the rate limiting, which we were setting up, we can call it now that this dot is cooling down. We have to pass the user ID. Now inside here we can say const fall back. We can call the result cache dot get build cache key, pass the user ID and parsed. Build cache key, I guess these are giving error because we added here async and we don't need to add here async. Yeah, now no error, it's not an async function. After this we can say if there is any fallback, then something is wrong. So fallback, then we can return the race dot we have to return something. So we can say return the fallback true, the cached true, the count, which is going to be fallback dot rows dot length, total count, that fallback dot total count, and the logs fallback dot rows. Yeah, that's all. Now after this one, it's basically ending here. Yeah, see, sometimes you feel confused like I'm feeling. Yeah, this one here, we have to make right now the cache key. So filters, we can add the limit, the type, the env, the app name, the search, the timestamp from, the timestamp to. Yeah, then const our cached key, we can call the build cache key, then the user ID and filters, and const cached our result cache dot get with this cache key. We're basically like checking the cached data. If there is cached, and minus cache dot ts if it's more than 1000. Then inside here we can say the cached hit, and we can basically return our cache true and the count, which is going to be the cache dot rows dot length, and the total count, it's also going to be the cache dot total count. For logs, it's going to be the cache dot rows. Yeah, that's all. Now we have to write the query comment, the most important part. After this we can write it. So still we're inside, right, if I'm not wrong. No, somehow I went outside. So actually here const where the user ID is our user ID. We have to basically add a type in here like string. Then if the timestamp from, then where dot push our timestamp more or equals to from, sorry, I mistakenly pressed command is, okay, from UI integer, it's like the type 32, integer 32, but since we're writing SQL command, so that's why something like this, at UI integer 32. If our timestamp 2, then where dot push, we have to push the command like the SQL command, timestamp less equals to our 2, that same UI integer, integer 32, the type is going to be. Now if our type, then we have to push the type, and the type is actually string. And now if env, then we have to push the environment. If app name, we have to push the app name like this, that string. And if search, we have to push the search. Yeah, that's all. And we need our query logs command. Now it's the SQL command. So select everything from our logs dot events, where the joined with this and order by timestamp descending, and limit it's going to be the EU integer 32. That's all. Then again, we need our now second, that math dot floor. I know we're writing a lot of code in here because basically this module is for so many like queries, so we are validating it one by one. And const from 24h, that's why it's a little bit like bigger than the normal code base. We're basically checking the from 24, we're transforming the time, so it's just like plus 24 hours in second format, and 224-hour is this now second. Yeah, now const where our 24h, the user ID, and string. Now where 24.h push, like where 24 hours dot push timestamp, sorry, something like this, that more or equals to from 24h u integer 32. Yeah, and where 24h dot push timestamp our 224h u integer 32 again. That's it. Now we need our query count comment. So query count, for the query count, we can write this SQL command. Let's select count as total from our logs.events table, where 24h dot join. Yeah, that's all. And then we can execute this query. So rs logs and rs count await promise dot all. Here we can write the ClickHouse query. So ClickHouse dot query we have to pass the query command, which is going to be the query key, query logs. The format is going to be JSON each row. Query params, it's going to be the user ID, the type, the env, the app name, search, and from is going to be our timestamp from, and to is going to be our timestamp to, and limit, the limit value. Yeah. Then from here we can again say ClickHouse.query, and the query is going to be this query count. This is for the query count, like for the full length. So this is not a normal query. We're basically adding a query call, something like that in here. We're checking for our query count. And query params, we have to pass the user ID here, the from 24h to 224. Yeah, like last 1 day query count. That's it. Then const rows await that rslogs.json, then const total, it's going to be await rscount.json and as any. Now we have to cache for 1 second. This is funny, we are doing it so that the repeated request goes from the cache. So we can pass the total and the ts, which is going to be date dot now. Yeah. And finally we can return our count, which is going to be rows dot length, total count, the total from the timestamp from to the timestamp to, and logs the rows. Yeah, that's it. And we still have to write some more code, but for now actually it's fine. It's ready for now, we can say. For the getting logs, it's fine, because for like rest of the work we still need to make this analytics, which is not hard, but yeah, we have to write some other lines of code. We will do that, but not definitely now, because we're currently working with logs module, not with the analytics module at all. Yeah, so our backend is actually ready. Let's come back to our controller, and here we have to add this new controller. I mean, not controller, new endpoint, like gate. And here we can say that our simple logs, okay, sorry, logs, and I think simple logs is fine. So here gate is going to be empty. You don't need to add anything in here. And we can say async get logs, and it's going to receive our request. Yeah, so we just need to send the request. Let's use a request decorator, request any, and response, sorry, response. Yeah, I have to call it. Yep. Then here we can return this dot our log service dot get logs, and we have to pass the request in here. That's it. We can save it. We can actually cut this and we can add it at the first, which will looks actually good, and it makes sense that first this empty gate means /logs is going to get these logs. However, since you're already protecting it with AuthGuard, so first thing is going to be the AuthGuard. If you're not logged in, you're definitely not going to get the logs from here. Yeah. Our backend is ready. Right now, we have to start to work back again for our npm SDK. We have to finish it right now. Since we're having the data, we can finish it for sure right now. We will come back here again and we'll finish the SDK. So yeah, let's start to work for the SDK now. All right, we'll come back. Let's go to our SDKs and OneMinute logs next library. From here, let's go to utils and index.ts. We have to start to work from here. After this private async flush module from here, we have to add our async and get this time for retrieving the historical logs from the server. Here it's going to receive the filters for basically the query, and the type is going to be record string and any, and it's going to return get is which lacks return type, and okay, fine, it will be fine. After some time we have to return something. Here we mistakenly forgot to finish it. Yeah, not here. Now inside here we can set up the headers. So headers, which is going to be record string and string, the type, and here we can pass our X API key, which is going to be this dot API key, and we can spread this with this dot app name, or our, like if it's available, then XOML app name. We are setting up this value to this dot app name, otherwise empty object. Yeah, and we can copy this time. Same for environment, and XOML env this time, and environment. Now we have to set up the queries. So const qs and filters and object. So object dot keys filters dot length. If it's less than 0, then we have to build these queries. We can say new URL search params from the filters, then dot to string, or empty string. However, the first bracket, I mean the backtick or like these quotes, will end in here, and otherwise empty string. This is the queries. Now let's send this to our API. So we can say await fetch this dot base URL / logs, and we have to pass this QS, the query and the headers. Yeah, that's it. If race dot OK is not true, it means there is something wrong. There is some error. Then const text await race dot text, and we can throw a new error, something like this, that OML get failed with our actually let's do one thing. Let's add here this package, and we can say res dot status, and then for the text we can add the text dot slice the first 200 value. Yeah, and then we can return the res.json. After this, the most important one, that is our streaming endpoint. So we can say public stream. This is going to open a server sent event stream of like the live logs. Here it's going to also receive the filters, which is going to be same record string and any. No, this one is string and string both. It's going to return body, which is going to be readable stream, and type is going to be uinteger 32. Actually uinteger 8 array. Yeah, the type. Then here let's come inside the function and we can say const qs equals to new our URL search params. You have to pass the filters and let's make it string. Let's make our URL right now. So we can say this dot base URL / logs and stream qs. Yeah, the query string. Now const headers. We have to pass headers in here as well. String our X API key, which is going to be this .api key, and let's copy this, the app name and the environment. Yeah, that's it. Now most important, after this we need an abort controller, which is going to be new abort controller, and const readable, new readable stream. Type is going to be uinteger 8 array, and here let's call the start. It's going to be an async function like controller. Let's return our race await fetch, pass the URL and the headers and the signal, which is the abort controller dot signal. Yeah, if our race.body has any error, then controller.error new error, and we can say upstream stream unavailable. Yeah, after this we can return the function something like this, and then we need on reader for our response. So res.body.get reader, and let's add a try catch statement. While true, then const done and value, we can extract it from our this reader dot read. Yeah, if done, then break. 1 minute, something is wrong here. Let's cut this, let's add a second bracket. Yeah, if done, then break. If there is value, then controller.enqueue and pass the value in here, and controller.close. Yeah, we can save it. If it catch any error, controller.error, pass the error. If it's cancel, if it get cancel, abort controller.abort, we can call this. That's it. And finally we can return the body, which is going to be this readable. We can save it. Our transport is ready, and since transport is ready, it means everything is ready. We can come back again into our core. From here we can uncomment this, However, this one, because of wrong, one minute, wrong syntax, and why it's giving error. Filters, 1 minute, stream. So here, filters and gate. Okay, we can copy the same type in here and we can paste that in here as well. So instead of string and string, let's say it any, then the error will begin. That's it. Our everything is ready. We don't need security, or just keep that in there, no problem. That's it. Our everything is ready. Let's come back to here. Let's try this command again, npm run build. Here we go. Now we would like to see the sent logs inside our front end. How can we do that? We have to right now make our live logs dynamic. So let's come back into our apps, main dashboard, app, live logs, and from here we can try to do it. We can basically come back down into here, and here where is our main function? Yeah, this one. Here we can do one thing. We can say const something from our gate stream. So gate stream is coming from our OneMinute logs next. So we have to import it from our OneMinute logs next. Okay, the error is natural. Let's do one thing. Let's come back to our index.ts, and from here we have to export everything. That was the problem. That's why it was not working. So if you're not exporting it from our this OneMinute logs next, then nothing is going to work. So let's come back here and let's say export our gate logs from ./utils/index.js. What it's saying? What? No, there should be on gate logs. One minute. Actually I think something wrong here. This is the transport, not the gate logs or gate stream. So for gate logs and gate stream, we have to use it. That's the problem. So let's create here a file by giving them getstream.ts and getlogs.ts. It's not done yet. Exactly. Now, since this is for Next.js, we have to use here use client, and we're going to add here and type for the filters, type for our the logs results, where we're going to receive the data is loading. The type is going to be error, and refetch, for refetching the logs. Yeah. Then we need to make on in-flight fetch promises by the query key to prevent the duplicate request. So we can add on map like this in here. Then on simple response cache key by the filters derived query string. That's why we're adding another map in here. Then we can start our main function that get logs, which type is going to be t any, and filters. We can call the filters. It's going to return the get logs result, the t, and here we need some use state hooks like this. So let's import use state from our React, like we need all of these hooks. So we can say import use effect, use state, use callback, use memo from React. However, it's saying we need to install the types for React. Okay, let's do it. Let's add our types for React. Okay, now no error. Now after this, we need our key. We have to use the build key to create a stable key for like the deduping or the caching mechanism. So we can say use memo, and we can use a function, actually an helper function called build key, where we'll pass these filters, and we can add the filters as the dependency array. Let's come back here. Let's say build key and params, which type is going to be record, string, and any. Yeah, now inside here we need our URL search params, and if the params are like the empty object, then we're running here for each loop, because this params is basically an array from the object. And then if the v is not undefined or v is not null, and if string length is more than 0, then we are basically appending it and making it string. And then finally we are returning it to unstable key, which is useful for usable for as a query string. Now we can come back here. These are basically our query keys. Then like the build key, which we can use to create a stable key for like the caching. Now here we can say fetch ons. This is for the callback. Async k is going to be string. If cache dot has our k, then return the cache dot get the k. Now we have to, at first this is basically for the cache, like when there is caching result, then we're serving the cache result. And otherwise, let p equals to our inflight dot get the k, meaning we are reusing the inflight promise for the identical filters, which is going to prevent the double fetch in strict mode, because when you're using the React strict mode, it fetch data for twice, which we want to avoid in here. If no p, then const URL, which is going to be /API /1minute logs /logs, which you have to set up actually. I mean, not you, our developers will give a suggestion for it that you have to set up this, because this thing we cannot run it from front end side, because this is a front end and we don't want that you run this type of query from front end, because it's going to expose your API key, which is dangerous. So that's why we will recommend you, or not recommend, we will tell you that you have to create an API key in your like Next.js project, something like this, that 1minute logs and then /logs, and we'll give you the code. You just have to copy paste, nothing else. Like we will give the code to the users, like for the developers who are using our application. Here we can say fetch. We have to pass the URL. Cache, it's going to actually no cache. Sorry, no store, not no cache. And then async res. If no res dot OK, then const text await res dot text. Now we can throw a new error that failed to fetch logs our res dot status on the text. Yeah. And then finally we can return the rage.json, and in flight dot set we can set the K and the P. That's it. Finally, we just need on try catch statement in here. And we can call const result. We can add that await P and we can set it to cache. So cache.set K and the result. And we can return the result from here. For catch, we don't need anything. So we can say one thing. We can say finally in here. Finally, we have to make the inflight.delete. We have to delete the K from here. And let's add our dependency array. Yeah. Because this fetch once it doesn't use callback. Here this is our everything, and however, wait, let me check one thing. Try catch. Yeah, everything is fine actually. We need to make another fetch logs use callback function now. Something like this. Here, let's add a dependency array. Inside here, we can at first add on try catch statement, and here we can say set is loading. At first make it true, the state. Then set is set error, make it null. Then we can say const JSON, await our fetch ons, and we can pass the key in here. Key as any. Now after this, we need our rows. So we can say array dot is array. We can pass the JSON as key and empty array, or JSON dot logs, or JSON or an empty array. Then finally we can set the data into this set data state. I mean, in our set data state, we can set the rows data or empty array. If it's catch any error, if the error name is not abort error, here let's add a type for the for the error. Then set error E, and after this, sorry, error, not E. After this, set data null. Yeah. And finally, we can say set is loading, which is going to be false. And in the dependency array, we have to add the key and the fetch ons. Yeah. And then at the end, let's use our use effect snippet. And here we're gonna call the fetch logs. In the dependency array, we're gonna also pass the fetch logs. Then finally, we have to return the data, the is loading, the error, and another function which is called refetch. So refetch actually, yeah. Use callback, async, and let's call the refetch in here. Now inside this, we have to clear the cache, so we can delete the key from the cache and then await fetch logs. We can call the fetch logs function from here. And regarding the error about this key, you can see it's saying argument of type void is not assignable to parameter of the type string. The reason is very simple. In this build key, we did a small mistake. The return should be outside from here. Yeah, after fixing it, you can see no error. And in that case, we don't even need to add this as any. It's going to work as well. No problem at all. So that's it. Our get logs is ready. And we don't need that open editors. Yeah. And next one is JetStream. Very, very important. JetStream is, we have to set up it. It's also going to be a little big, like this one, actually more bigger, because streaming is the biggest setup in here. So let's start. At first, we have to create here our the filters, the same filters, and our log level. These are our log level, and we have to add another type for our streaming the log into normalized version, like ID, TS, level, source, message, and payload. Then we need our another type for stream log row. Stream log raw, not row. We have to pass the key ID in here. We need our user ID. We need the type. Then some other fields which we're always adding, something like this: message, app name, environment, importance, subsystem, operation, track, security metrics, and then timestamp, and the ingested add. Yeah, all of these. And after this, we need another actually type. This is for getting our stream result, something like this. And that's all. But at first, we have to add here actually this import statement that import our use effect, use ref, and use state from React. And let's add use client in here. Now, after this, we can come to our main functions. We can say export function the get stream. It's also going to receive the filters, and it's going to return the get stream result. And we can say const data and set data loading, and is loading. Then error and set error, connected and set connected, and ESREF, like the reference use ref. And these are the types. You can just pause it and write it by yourself, just like some state which we need. Then we have to write here on use effect. So use effect snippet, and in here let's delete everything from inside, and const qs, like the queries. So we can say filters and object dot keys. We can pass the filters dot length if it's more than 0. Then our new URL search params. Then object dot entries. We have to pass the filters dot reduce record string and string as the type. Then here we can add our type, something like this. I know it's looking a bit weird, but this is how we have to work in here. It's going to actually objects. Yeah. No, actually object, not objects. It's fine. Let me again check. It's actually fine. And entries, filters dot reduce. All looks good though, no problem. We can come back here, and here we can say if our v equals to not undefined, then something like this, string, and let's pass the v in here and return the ACC. I think somehow I finished the statement. Yeah. Oh, crazy syntax. Let me again check from the beginning. So here we said if the object dot keys. Let me take it in the next line, and I can easily read. And after this, new URL search params.
Let's take it next line. Object.entries and filters.reduce. Record string, all good. But here I think we have to add another first bracket. And actually it should be K. Yeah, K and V. If V equals to undefined, then this is fine. And return ASC, this is also fine. This part looks good. However, here we have to add another first bracket, actually 2, then dot to string, and then finish it. Otherwise, an empty string. Now you can again check it. It was definitely not easy syntax to follow up, but yeah, you can just check it now. Then we have to check for the event stream. So new event stream, we can call event source, not event stream, and it's going to be /API/1minute logs /stream, and the QS we can pass. However, we must change it to the backend then, and then esref.current equals to es. Then we can call the set connected, and we can pass the true. Set is loading, let's make it true, and set is error, let's make it null. And es on message, this is basically the server event setup, server sent event setup. It's going to receive the event. We can add here on try catch statement on the try part. Let's receive the payload. We can say json.parse event.data. Now we can add the set data value in here. We can select incoming, which is going to be stream log normalized array, and by default value is going to be an empty array. Now we have to handle the different shapes like type, logs, and everything. So something like this, let me write it quickly. If the payload and array is array the payload logs, then incoming, let's set the payload logs. And toLog entry, this toLog entry is basically on helper function which we have to create. So let's do it. Let's come outside from here. Let's create our toLog entry function, which is going to receive the L, meaning log. Type is going to be the stream log raw, and it's going to return the strip log normalized. Now we need our raw type, something like this, then the level, and based on the level, like the raw type, if it's warning then warning, if it's success then success, if it's error then error, debug then debug, then audit then audit, and metric then metric, otherwise by default info. And we have to set on TS ISO time, and then we can say if our type of the L.timestamp is number, then we're setting it to in here as the timestamp value. Otherwise else we're basically handling like the JSON row, each row value, which the like in our ClickHouse DB, the timestamp is stored like this, like year, month, and date format, and something like this hour, minutes, and second format. So we're basically formatting it in here. And then finally we can return id crypto.random UUID GSISO, the level, source is going to be L.app name or default, message is going to be L.message, and the payload itself something like this. We can save it. Now after this, our this toLog entry function is ready. We can again come back here where we were using the toLog entry. Now here we can say else if our the payload is an like array in here, then incoming we're basically adding the stream log raw in here. And else if the payload and payload key ID, then we're again adding that in here like that. After this, if our payload type is initial, then the next equals to going to be the incoming, and set is loading is going to be false. And next length, if it's more than 5,000, then we're basically slicing it, slicing the array. For the next, we're adding the previous and incoming, and if the next is more than 5,000, then we are showing like less data. So it's basically meaning when the live streaming is having more than 5,000 logs, then we are basically like filtering it. Not filtering, we are like splice, we are using a splice method so that we can remove the older logs and we can show the updated 5,000 logs. Otherwise, definitely the client side is going to be very heavy and somehow the application will crash, like the front-end application. That's why we have to ensure it that we're not streaming more than 5,000 logs at all, like at once, not at all. Yeah, that's why if it's more than 5,000, we're like slicing the last 5,000, and rest of the previous log, we're deleting those. And then finally we can return next. If it's catch any error, we are basically setting the value, and here we have to say any as the type, and we can add here in console.log that OML stream. This is for debugging purpose. Failed to parse SSE message with the error message. Yeah, done. After this I'm getting exhausted. I'm recording for a long time. However, we're very close, so let's finish it. Here we can add another console.log. If it's catching another error, we can say OML stream SSE error, and we can pass the error message in here. We can call the set error instance of the error or the error itself, a new error. We can pass the SSE error message in here. Yeah, and finally we can return our es.close, and the set connected, we can make it false. In the dependency array, we have to say json.stringify, and filters are empty object. Yeah, and we have to add another one for disconnecting it. So disconnect, it's kind of similar like the WebSocket setup, but it's not fully same, because I already explained it what the difference between WebSocket and server-side events. It's not the same thing. And here esref.current, we can add here null. We can call the set connected, and we can set false. And at the end we can return this getStream function. We can send the data, the is loading, the error, the connected, and the disconnected. Now see, no error here at all. Everything is ready. Our getStream is ready. Now in this index.ts, it should not give actually error. It's giving the error because it's looking from the index.js. That's why. If it's go to our get logs, then it should not get any error. Yeah, same for our like the get stream. So get stream and get stream, no error. We can save it. We can come back here. We can again build. After building, if we come back here, it should not give us any error, and you can see it's working perfectly. So we can save it. We can call the hook because this is actually on hook, and we can take our data from here and we can give it name like nothing because data is also fine. We can console log the data. Definitely it's not going to work. If you go there, it's going to get an error because there is some requirement for setting up this. We have to come back to our API folder again, and in our API folder we have to create 1-minute logs folder, 1-minute logs, and here we have to create another dynamic folder like this that types. You don't have to, I'm not doing it like blindly. These things are already mentioned in the documentation. You just have to go to the documentation. For you don't have it yet, but we will create the documentation page where we will mention all of this. You just have to copy the code base like this and paste it. That's it. However, in here we were using the like next auth, which we're not using in here. Auth options we don't need. Get API key, I don't think we need any of this. However, get API key, what it's doing. Okay, this was basically for our auth. We don't need any of this since we're using actually Clark. API key, for the API key value, it should be actually an env value, so we don't need this at all. We can just check for the auth, and for checking the auth we don't need all of this code base. We can delete this next auth because we're not using next auth. We can use your Clark. We can simply import here get token from our auth hook from Clark Next.js, and especially Clark Next.js / server we have to say here. If there is no token, it means like user is not logged in, and token is coming from here, that our like get token, this hook. And after this, if there is no token, we can say unauthorized. Yeah. After this, the API key, most important part, API key is going to be process.env dot 1-minute logs API key, and make sure that you are adding this 1-minute logs API key in your like env like this. And actually 1-minute logs something like this, so I think I should change it to yeah. So I already do have this. You just create an API key and paste it in your env, not env example. For you I am showing it in example, but for me I like already added in env.env, and you also have to follow the same thing. You also have to add it in your .env file. After this, I think everything should work after this, so we can test it right now. Everything we can test. How to check? Let's come back to our live logs. Actually, let's inspect at first. Let's make it small. Let's come to live logs, and it's showing empty array. Oh, here you go. You can see we are having 2 logs in here. Wow, interesting. It means it's actually working. That's really great. So now we can set up this. We can change our this page.tsx to a dynamic value because we don't need these static logs anymore right now. Since we're having our dynamic logs, we can delete all of these except the types. Yeah. Let's make it dynamic now. So first of all, in here, we can cut this. We can add it in here. We don't need these logs and set logs right now because we can call it logs, and we need on state for our auto scroll filter level and everything, it's fine. We can delete this use effect. Here stream ref fine and use effect. Actually here we have to write on logic that if no auto scroll, then return, otherwise this, yeah, and logs, then the auto scroll as the dependency array. For filtered logs, it's actually already fine, I guess. Yeah, it's fine. For stats, I think it's also fine. Now for live logs, all of this should be good enough. So still there are 2 errors, especially the level color. And level color is giving error because it's saying cannot find level color. I mistakenly deleted the level color from here, so we don't have to delete it. Const level color record log level and string. Yeah, what's wrong in here? Okay, because we have to add something in here. Record level color info is going to be this one, blue. Warning is going to be yellow or amber. The error is going to be definitely the red. Debug is going to be the purple color. The success is going to be our green. Audit same, and metric is going to be the cyan color. Sorry. Yeah, now no error. We can come back here, everything is fine. Let's come back to our live logs, and here you go. You can see it's actually real logs. Even if we click here, it's showing us the real data. Now I want to do one thing again. Let's come back to our this test, because we were basically testing our live logs from here. If we go localhost 3001/test, sorry, /API/test, you can see there will be one new logs. You can instantly see it's automatically coming and it's updating every 1 second because it's the real log. So let's try something new. Instead of error, let's say success, or actually not success, let's say info user ABC logged in, and services we can say auth, importance we can say low. Let's save it. Let's come back here, give on reload. We can come back here again, and here we go. It's real time. We're not giving any reload, still it's in here. So it's definitely really very interesting and very beautiful. We can even change this. You can see it's actually working. You can change from here and it's all going to work, and it's all fully real time. You can check from here as well, the all data, the raw JSON, and everything from here. It's really great. Now the next one, we can finish these queries. Since we're having our log data, we can make the queries. After that, what next? After that, we have to make this like this logs, error rate, ingest rate, like the analytics. This is very, very important. And at the end, we will start to work for the alerts, and then everything will be actually done, because integration, it's basically the documentation. Alerts, a new feature, and queries, we already have it, everything. We just have to make it dynamic. So let's do it. Let's come back to our page.tsx in main dashboard, app, and the queries. Exactly. Now in here, let's make it dynamic. In here, at first, after this filters and set filters, we can say const something from our gate logs hook. So OneMinute log/next, and here we're gonna receive the data that is loading at the error. So error and is loading. Let's make it dynamic now. After this, next task is, the next step is, we can come down in here, and before this normalize query, we have to create another use callback function. Actually not another, it's probably the first one. So let's say normalize our logs. So we're basically going to normalize the logs type. So normalize logs, we can say react dot use callback. We're going to receive your input, which type is going to be any. It's going to return the result row, which is going to be an array. Now inside here in the dependency array, we can keep it empty now. Now if no input, then return on empty array. If array dot is array, the input, let's pass the input in here. If the input is an array, then return the input as a result row, an array. What it's saying, if the array is okay, we have to finish the last bracket in there. Yeah, now here we can again copy this, and this time actually in between we can say const object input as logs, and type is going to be any. Now here instead of input we have to pass object dot logs. Yeah, and return object dot logs. That's it. And finally return an empty array if not any of these. Then and now normalize query, it's fine, we don't need to do anything in here. This one also perfect. Parts looks good to me, and this one also fine. The results in these rows, it's different because right now we're having the dynamic data, so we don't need any of these actually. Yeah, so we can do one thing, we can delete everything from here since we're having the dynamic data. So let's delete everything and let's add our rows variable in here, and let's call the normalize logs, pass the data, and then we can return the rows or empty array. In the dependency array we need the data and the normalized logs. Yeah, all good. Stats looks good to me. If we save it, here it's giving some warning, we can just change it with like the cessation. It just tailwind CSS cessation, not any big deal. But if we change it, then the ESLint will not give any warning. Yeah, and there is one more somewhere. Okay, here, this one, what it's saying. No, not AI features, sorry. Where's that? The class can be written as W1, but it's already that. Fine, ignore it. It's not any big deal. And we don't need this static query results then. And yeah, we actually don't need that. And regarding filters, our get logs, we have to pass the filters in here. Yeah, very important. Now we can come back here and queries, it's fully empty, given reload. And let's see if it's having any data. It's actually showing pending. There is something wrong. I don't think so. Why it's still pending forever? Get logs from our OneMinute log / next. Let's console log the data. It's null. Okay, there is something wrong for sure then. And what's up the is loading? It's true. It's forever true. Okay, interesting. So there is something wrong in our get logs. We have to check it out what's wrong. So we can go back to our SDK again. It's indicating that there is something wrong in here. I'd like to check the set is loading. It's true, then set error null. And here the finally set is loading false. We set fetch once, and fetch once is here. Where's the fetch once? Yeah, this one. Actually, I think we have to add here slash. That was the mistake. If we give a reload now, we have to update. I mean, since we updated something, just rebuild it again. Give a reload. Still weird. It's calling the OneMinute logs. Yeah, and preview. Nothing. It's loading forever. Alright, so I found the bugs in our code base. It was definitely not any big mistake, but yeah, at the same time, it can be a big mistake. First of all, in here, we are calling the response, but we're not sending it response from here. So we just have to delete that. We don't need to call that at all when we're not using it, because we're not sending that from here. So we need to just delete that. Secondly, it's a minor mistake, but it can be a big mistake, and that is in our, like this, sorry, not here, scroll down, not the result cache, but in our parse filters. If you notice, we're not using await anywhere when we're calling the parse filters, but in here we're using async. So it's actually going to load forever because of the mistake. So just delete the async from here. Now from here, if you come back here, you can already see the data, but if I'm giving reload, you can see the data are coming here properly. And it's actually working. Even if we see type error and hit run query, here you go. The 3 errors in here. If we delete and if you hit clear, you can see the 4 data in here. So it's perfectly working. And right now, we can delete all the console logs. We don't need that, which we added for like debugging purpose. So we don't need to open any of these files. In here also, we don't need this logs, console log. In here, all good. But one more place, I guess, in here somewhere. Especially in like our utils, get logs. Yeah, let's delete it from here. And that's it. I think everything we deleted. Now let's come back here, give one reload, and let's check our console. No, it's still there somewhere. The somewhere is in our page, so it's fine. Let's close all of these. And let's come back to our page.tsx in this queries, and the logs is in here. We don't need that. We're already having the dynamic data, so we even don't have to change anything. We're very lucky that everything is perfectly working in here. If we run this query, no data, because we don't have any data like that in here. You can see everything is perfectly working in here, and it's interesting. Everything is clearly working. Now what next? The next step is we have to setting up the billing, and billing is very, very important. We have to make another card for that. And this analytics, it's also very, very important. And at the end, we can do our alerting mechanism. Like you can set up alert from here. By using this alert, you can like set up some custom, let's say some conditions that if there any this type of error more than this amount, then please notify the admin, like send an webhook request, and then you can do any whatever you want. You can like send a Slack notification or send an email or whatever you want to do after receiving that like webhook notifications. And these things we will do in our next part. That's going to be the last part of this like 1-minute logs video series for our this monitoring SaaS application, because this first part is already very long. I am recording it for a long time, and since it's a very big application, that's why I'm dividing it into 2 parts. In the next part, we will finish it and deploy it. If you have any question, feel free to ask me in the comment sections. I would love to answer that. See you in the next video. Till then, take care and bye-bye.